So, very warm good evening to one and all present here, the esteemed speakers, honorable participants, guests. It is our pleasure and our honor to invite you all to this FDP Smart Manufacturing and Industry 4.0, the future of production. I, Dr. Navita Gurbani, along with Professor Sarmishta Sharma of Asian Business School, take immense pleasure in welcoming you all to this FDP. Asian Business School is a part of Asian Education Group, an innovative center of academic excellence approved by AICTE, NBA accredited, and is one of the top colleges of pgdm in India. This FDP is organized by IQAC and RDC cell of Asian Business School. We all are very much aware that IQAC and RDC go hand in hand and are continuously involved in the excellence in education, corporate governance, and community engagement. With their quality enhancement, monitoring, education, and evaluation and capacity building program, this FDP has taken its shape. Let us not further wait more, and we shall start with our program very soon. We have the esteemed presence of our director, Sir Dr. Lalitya V. Srivastava, under whose guidance and mentorship this FDP has taken place. We are also honored with the presence of our Dean Ma'am, Dr. Shweta Batra, whose continuous expertise and guidance has made what this FDP is what it is. Moving on to the crux or the first area of FDP, that's why this FDP is the need of the hour. The FDP is designed and developed to equip educators with cutting-edge knowledge and skills in the areas of Industry 4.0, smart manufacturing, Internet of Things, and AI in manufacturing. The program will help faculty members to integrate the advancements into their teaching and expertise. As we all are very much aware, the gap between the industry and academia is far relevant and is well known. We at Asian Business School are trying to fill this gap by having knowledge sharing from people across the globe, sharing their ideas and experiences to enable faculties develop more in their practical terms. So without waiting further, let us welcome the speaker for the first session, Dr. Abhijit Sarkar. So participants, there is a little request from my side. If there are any queries or if you want to have a question directed to the speaker, we request you therefore to write it in the chat box so that your query is resolved at the end by the speaker. And of course, the query is not lost in the progress of the session. So you can use the chat box for having pen downing your suggestions or maybe your queries relating to the sessions. As you have all known that today we'll be having two sessions. One was starting from 6 to 7:30 and then 7:30 to 9. Your esteemed presence is required in both these sessions. Post these sessions, we'll be circulating a feedback form for all the participants that you can access through the chat box only. And it is required that you fill that feedback form by today. So we'll move on to the first session for today.
Yeah, hi, good evening to everyone out here. Am I audible?
Yes, sir.
Okay. Thank you. I would like to thank Dr. Sharmishta Sharma and the the other managing committee of Asian Business School, Noida, for giving me an opportunity to present my say on the transformation of manufacturing process from conventional to 4.0. So before I go to the next session, to the detailing session, I would like to start sharing my screen. Is my screen visible?
Yes, sir. Your screen is very much visible. I just wanted to introduce Dr. Abhijit Sarkar to the fraternity present here. Sir is a distinguished entrepreneur and accomplished leader, currently serving as a partner and board director at Premium Tech Solutions, one of the most respected names in the industry for providing a wide array of technical services tailored for corporate clients. Prior to his current role, Dr. Sarkar has substantial experience as the Senior Vice President and Country Head of Administration Procurement at Sher Khan Limited, a wholly owned subsidiary of the French multinational bank. So, sir, over to you. Apart from all these expertise, I would say that sir is very much sought after management consultant in many of the institutes. We are honored to have your presence, sir.
Thank you, Doctor, and it's really privileged because connecting with students has been always my passion, and I'm really honored to connect with them once again. So I'm taking out to the next slide because you have already explained, the audience about my background. So before we go into the core subject, I would like to start about the fact, that it's very imperative for everyone to know what is manufacturing. Before we get into the revolution 1, 2, 3, 4, it's very imperative to understand in a layman language what a manufacturing is all about. So if I have to speak about manufacturing in a simple word, it's a process of converting raw material or components into finished goods through various processes, tools, and labor. It involves a series of steps that includes design, production, and assembly to create products that can be sold in the market. So manufacturing is essentially a process for economic development, creating jobs, and providing goods for consumption. So precisely it is something that, from raw material, you are converting something into a finished good through a process which is called a manufacturing. So there are multiple processes of manufacturing, I would like to talk a bit in detail. One is discrete manufacturing, the other is uh, process manufacturing, then third is job shop manufacturing, fourth is batch manufacturing, fifth is continuous manufacturing, and sixth is additive manufacturing. So I would like to touch upon these processes bit in detail. Am I audible?
Yes, sir, you are now audible.
Okay, okay, my apologies. So whatever I spoke in the beginning talking about manufacturing, was it heard by the student or I have to restart?
No, sir, you were muted only for 5 seconds or so.
Okay,
So,
okay, okay, no problem. So, I would like to touch upon the types of manufacturing. So, discrete manufacturing, if I have to describe, it involves a process wherein the production of distinct items that can be individually counted and categorized. Products are made in separate units or pieces which can often be disassembled if needed. Characteristics, basically the production process can involve assembling parts, and the items are usually produced in smaller quantities or in batches. And if I have to cite an example for this, automobile is one of the best example, wherein cars are assembled using individual parts like engine, wheels, electronic, etc., and each car is distinct identifiable product. Now, second, if I have to talk about is a process manufacturing. So process manufacturing usually focuses on production of goods that are produced in bulk or in volume and cannot be disassembled like what we talked about in discrete manufacturing. So here, the parts of manufacturing is often used for products that are created through chemical, physical, or mechanical process. So characteristic of this is, the final product is typically a liquid or a gas or a powder form, and the process is continuous or occurs in batches. So if I have to cite an example of a process manufacturing, a drug or a chemical mixture, once created, cannot be broken down into its individual ingredient. So cement production or oil refinery are some of the example which can be correlated or which can be linked to process manufacturing. So third type of manufacturing is job shop manufacturing. So job shop manufacturing involves the production of small batches of custom or made to order product. Each product ideally is manufactured based on the specific customer requirements, and the production processes can vary significantly between these jobs. So if I have to characterize this, it is highly flexible method wherein the setup is customized for each job. The process typically handles low volume and high in variety. So customized furnishing, manufacturing is one of the example of job shop manufacturing. Each piece of furniture may be designed and built according to the client's expectation, based on the client's requirement or based on the design proposed by the client. And apparently, the meaning of production process can vary from each job. It may not be, uniform. I may have some design, the other person may have some design, so the design may not be uniform. It will change on a case to case basis based on the requirement of a client, and it is always customized. The fourth way of manufacturing is batch manufacturing. So in batch manufacturing, products are made in specified quantities or batches at one time. So each batch goes through the entire production process together before moving into the next level or the next stage. Batch manufacturing is typically used when the demand fluctuates or for seasonal products. So if I have to characterize this again, it is good when it balances between mass production and job shop manufacturing, as batches can range from small to large depending on demand. So if I have to give an example, a classic example to this, bakeries often uses manufacturing to produce bread or pastries. For example, 100 loaves of bread might be baked at one single time, and once that batch is completed, the next batch, perhaps the batches of cakes can be taken for production. So, so the next point I have to take over is continuous manufacturing. So continuous manufacturing is a type of process as evident from the word itself, which runs for 24 by 7 without any interruption. It's a continuous process. The material continuously flows through the production process and products are created on a large scale without stopping. So characteristics, it is highly efficient and used when there is constant demand for a product with a minimal variation. A classic example to this is steel production or a petrochemical refinery are one of the best example wherein you can demonstrate or justify how a continuous manufacturing is in process. So once the process starts, it runs continuously to produce a large quantity of the product. And the last one is additive manufacturing. So definition of additive manufacturing is basically commonly known as 3D printing, involves creating objects by adding material layer by layer based on the digital design. So this is a different from the traditional manufacturing, which often involves removal of material, subtractive manufacturing, and so on and so forth. So characteristic, if I have to say, it is used for producing high customized products or prototypes. So it offers flexibility and precision, but is often slower than the traditional method. So 3D printing is one of the core example of additive manufacturing. So what used to happen, when we talk about industrial revolution, manufacturing before the industrial revolution, the cottage industry. We know that cottage industry still prevails. It's not that it has been eliminated completely, but before we see or we saw the industrial revolution happening, the cottage industry was one of the main mechanism to manufacture goods. So most of the manufacturing was done from home or in a smaller workshop, wherein family would produce goods by hand, often working together to create textiles, pottery, or tools, and so on and so forth. What was the main source? Manual labors was one of the main source, wherein production relied heavily on manual labor, and the traditional techniques were used to make it slower and less efficient. Craftsmen used simple tools and methods which passed down through generations. Local markets used to prevail, wherein goods were typically made for local consumption, and production usually was at a smaller scale. So with items tailored to a specific community needs rather than for widespread distribution. So why did the industrial revolution start? That is the main methodology or main topic of discussion. So to start with, agriculture innovation, as we can see, Advances in farming techniques and equipments like seed drilling and crop rotation started, coming into picture. And apparently, what happened due to technology coming into place, the production became very rapid and fast. And this could happen with a minimum manpower as would required during the time when no technology was used. And as a result, only fewer people used to work in agriculture, prompting many to seek jobs in emerging industries. Natural resources is one of the reasons why the industrial revolution started. The availability of coal and iron in Britain provided necessary materials for powering machines and building infrastructure. Access to these resources facilitated the growth of industry like textiles and metallurgy. Technological advancement, innovation like steam engine and steam engine improved efficiency and productivity. So this technology made it possible to volumize product, mass produce goods, reducing cost and increasing availability. So truly understand the transformation from manual labor to mechanism in 17th century, we must look at the historical landscape of that era. The world was undergoing rapid change, which includes social, economical, and technological. The transition from agrarian societies to industrialized economy, which we now call the first industrial revolution, was driven by several key factors. Before this period, as I said, most of the production was done manually by skilled craftsmen. But while this method worked for centuries, it had limitations which confined to efficiency, speed, and the capacity to meet the growing demand and the expanding the global population and economy. So apparently, why did this shift to machine occurred at the particular time is the question what most of you could ask. So growing demand and population growth. It's very important that uh, to understand that how the demand for textile, food, and material increased in 17th and 18th century. So cottage industry and the rise of inventors and engineers leads to the creation of early machinery. So if I have to give an example, invention, as I stated, the water frame made textile production faster, more efficient, and less reliant on human effort. So accordingly, economic incentives and capitalism was one of the core fundamental which impacted in industrial revolution to start. Growing capitalized mind, profitability and efficiency. So there was a strong economic incentives to produce goods at a faster rate at a lower cost, wherein the landowners and factory owners invested in machinery to reduce labor cost and increase their profits. Accordingly, especially this was confined largely to the textile. Access to natural resources, one of the key fundamental access to coal, iron provided the raw material needed for building. Britain in particular had rich reserves, which became critical in powering steam engines and other machinery. So the development of steam engine by James Watt revolutionized the industry by providing a reliable source of power, enabling factories to away from workers, moved to cities like Manchester and Birmingham, wherein they found jobs in factories. So these cities become industrial hubs and producing goods like textile, iron, and machinery, driving the industrial revolution. So that is how the first revolution started. If I have to summarize this timeline from 1760 to present, the key feature included introduction of steam power, impact, growth of factory system and urbanization. Again, the second revolution key feature was widespread use of electricity, introduction of assembly line, impact was mass production and consumer culture. While we talk about third revolution that prevailed between 1960 to 2000, key features was automation and computerization in manufacturing, introduction of robotic and CNC machines, impact, increased efficiency and flexibility of product. Industry 4, that is 2010 till present, key features, integration of IoT, AI, and big data in manufacturing, development of smart factories and cyber physical systems, impact, enhanced efficiency, and real-time decision making. So the first industrial revolution overview, key characteristic I mentioned earlier was introduction of steam engine, mechanization of textile production, development of iron production techniques, growth of factory systems, shift from agrarian to industrial economy, significant urbanization and population movement to the cities. So invention of the first revolution, which I already highlighted, are spinning jennies, water frame, steam engines, and power looms. Rise of factories, that is one of the important things. Centralization of production, factories centralized production processes, moving from individual houses and small workshops to larger facilities. So this allowed for better coordination and increased efficiency in manufacturing. So mass production and economy of scale. The factory system enabled mass production of goods, significantly lowering cost per unit and making products more affordable. So this shift facilitated the growth of consumer markets. Labor change. Factory transformed labor dynamics by employing larger number of workers, including women and children, often in moved jobs from skilled craftsmen to unskilled repetitive tasks. Urbanization. The rise of factories spurred in the rapid urbanization as people migrated to cities, increasing population and challenges, including overcrowded living in conditions and social issues. So centralization of production, wherein factories centralize production processes, moving from individual houses and small workshops to larger facilities. Involved stakeholders and increase the efficiency in manufacturing. Goods and services. Centralization of production. If I have to talk about homes, as I stated earlier, known as cottage industry. In this system, people work with their hands or simple tools as technology improved and machinery were developed. Production process become too large and textile industry. In past, individual goods spin wool and weave cloth at home. But when machine like spinning jenny and power loom were invented, it became more efficient to centralize production in a larger factory. This allowed worker to operate machines together in one location and make production more efficient. This allowed worker to operate machines together in one location under one supervisor, which led to a better coordination of the production process, and finally it improved the output. Mass production and economies of scale. So when you have a larger production, definitely you save a substantial cost. That goes without saving. So the factory system made it possible to produce goods on a maximum larger scale, which is also known as mass production. So factory could now make a larger quantity of same product at a very minimum time frame, which also reduce the cost per unit. So this reduction in cost happened because when you make a lot of something, the overall expenses like labor and machinery are spread across a larger number of units, so leading to a lower cost per item. And this is called economy of scale. So example, if I have to cite, Henry Ford's assembly line for the production of Model T car is a classic example of a mass production. So by using specialized machines and workers doing repetitive tasks, Ford's factory was able to produce car at much faster rate than ever before. So this allowed him to sell car at a lower price, making them affordable for average consumer, which in turn expanded the market for automobiles. The third point I would like to explain is the labor changes. The shift from skilled craftsmanship, where artisans made goods by hand, to factory work had a huge impact on labor dynamics. Factories employed large number of workers to operate machines, and many of these jobs did not require much of skill. The work was often repetitive, which tasks broken down into smaller steps that anyone could perform. So this allowed factory to hire large number of even unskilled workers, including women and children, who were often paid lower wages than men. So unfortunately, working conditions in early factories were very dangerous and harsh, with long hours and little regard for workmen's safety. So example, in early cotton mills in Britain, children as young as 7 to 8 were employed to work longer hours, often in dangerous conditions. They operated machines or worked in a job that involved repetitive or monotonous tasks such as cleaning machinery or carrying materials. So finally, urbanization. As factories grow, they needed more workers. As the infrastructure goes, it requires a lot of people to be part of the expansion journey. So similarly, the workers were required were high skilled, high in number, which led to massive migration of people from rurals, where most of the people previously lived, to cities where the factories were located. So this process is called urbanization. While cities offered more job opportunities, they also faced significant challenges such as overcrowding, housing, poor sanitation, and increased social problems like poverty and crime. The rapid growth of cities changed the way people lived and worked, creating a new urban working class. So, example, you have to search Manchester, England, become one of the world's first industrial cities. So in 18th century, it rapidly expanded as factories and mills were established. People moved from rural areas to Manchester in search of work. However, the city struggled to accommodate the influx of people, leading to be overcrowded, unsanitary living condition, and this led to a variety of social issues, including the spread of disease like cholera and exploitation of workers in dangerous factories and environments. So, if you summarize, these points I have explained much in depth. In case of any question, you can put it in the chat box. The second revolution between 1870 to 1914. What was the key element of this second revolution? Technological innovation. The second industrial revolution, spanning from late 19th to earlier 20th century, was characterized by significant technological advancement, particularly in electricity, steel production, and chemical processes. The widespread use of electricity transformed industry, enabling factories to operate machinery more efficiently and extended working hours. Mass production and assembly lines. The era also saw the rise of mass production techniques, notably amplified by Henry Ford's introduction of assembly line in automobile manufacturing. So innovation drastically reduced production times and costs, allowing for rapid creation of standardized products. What you mean by assembly line? In assembly line, basically you have multi people doing specific job. It means if I am doing something, post I complete, it goes to the next person, and that's the cycle. And the next person complete, it goes to the third person. That is how the assembly lines function. Globalization and economic change. The second industrial revolution marked a significant shift towards globalization as advancement in transportation, such as railroads and steamships, facilitated the movement of goods and raw material across the borders. So today, if I have to ensure that the globalization is at peak, the connectivity across the globe matters, and second industrial revolution made that thing possible, wherein the connectivity across the globe was possible through railroads and steamships. People also saw the emergence of large corporations and trusts which dominated industries and influenced economics worldwide. So the key crux of second industrialized revolution was technological innovation. So the second industrial revolution, spanning from late 19th to earlier 20th century, was characteristics by significant technological development, particularly in electricity, steel, and chemical, and the widespread use For electricity, transform industries, enabling factories to operate machinery more efficiently. So before electricity, factories relied on steam engines, apparently, and on water power to run machines, which were less efficient and limited to certain locations. The widespread use of electricity transformed manufacturing with electric motors, factories becoming much more flexible in their design and location as they no longer needed to near water sources. Electric lighting also allowed factories to extend working hours into night, increasing productivity. So if I have to cite an example, Thomas Edison invented the electric light bulb, which made possible for factories to operate around the clock. Additionally, Nikola Tesla's alternating current, that is called AC system, allowed for the efficient transmission of electricity over long distances, which enabled industry in cities to flourish. So steel production, the invention of Bessemer process drastically reduced the cost of producing steel. Steel was stronger and more durable than iron. So it became essential for building railway and bridges and ship and skyscrapers. Example, Andrew Carnegie steel plants in the US were able to mass produce high quality steel, which became the backbone of the construction and transportation industry. Chemical process. The period also saw advancement in chemical manufacturing, particularly in the production of synthetic dyes, fertilizers, and explosives. The development allowed for the growth in industry like textiles and agriculture. Example, German chemical company like BASF and Bayer developed a process to create synthetic dyes, which revolutionized the textile industry by offering a wider range of vibrant colors and weren't available from natural dyes. Mass production and assembly lines. One of the most revolutionary aspects of the second industrial revolution was the rise of mass production technique, which allowed for the rapid and inexpensive production of goods. The best known example, if I have to cite, is again Henry Ford's assembly line in automobile. Assembly line basically broke the car building process into smaller specific tasks which each worker responsible for just one part of the process. So these allowed car to be built in much faster way with less labor. So instead of having worker move around the car, the assembly line brought the car to the worker, and that is what the Henry Ford had created. So example, before the assembly line, it took literally 12 hours to build a car. After assembly lines was introduced, it took only 90 minutes to build Model T Ford. So this reduced the production cost and Ford could sell these cars at much competitive price, making them affordable to the ordinary people, which expanded the market for automobiles. Third, globalization and economic change. As we saw, railroad expanded across the contingents, linking cities and allowing for rapid movements of goods. Steamships could transport goods across ocean much more efficiently than sailing ships. Example, the completion of the Transcontinental Railroad in US in 1869 allowed goods to be transported from the east coast to west coast in a matter of days as compared to the months by horse or wagon. So steamship like SS Great Britain made the international trade faster and more reliable. Economic growth and global supply chain. This interconnectedness expanded market and promoted international trade, leading to economic growth. Raw material could be sourced from one country, processed in another country, and those sold in third country. So this is where we saw the beginning of global supply chain, where different part of the production processes happened in different countries. Example, if I have to cite, British textile factories would import cotton from US, manufacture clothes in England, and then export the finished product to the market across the globe. And this increased the flow of goods between countries and expanded consumer market. Large corporation and trust. This era also saw the rise of large corporation and trust. wherein the business combinations that control the entire industry. These companies gained significant power and influence over the global economy. For example, John D. Rockefeller Standard Oil dominated the oil industry, and the US Steel, founded by Andrew Carnegie, became the largest steel producer in the world. Standard Oil Trust control almost all the oil refining in the refineries in US, allowing Rockefeller to set prices and dominate the market. Similarly, corporations like General Electric become leaders in production of electrical equipment globally. So, if you see, the second industrial revolution was a period of technical innovation, particularly in electricity and steel and chemical, which transformed the industry and made them more efficient. Mass production and assembly line allowed for faster, cheaper production of goods, making products like car affordable to a larger crowd. The period also saw globalization with advancement in transportation, railroads, steamship, etc., enabling the movement of goods across the border, expanding the demographic market and facilitating international trade. The era also marked the growth of large corporations that shaped industries and economies globally. So this development had far-reaching efficient shaping the modern industrial world and laid the foundation for interconnected global economy what we see today. Now moving to the third industrial revolution. So hope I am clear till now. Hello.
Yes, sir, very much.
Okay.
Thank you, sir.
Okay. So moving to the third industrial revolution, which existed between 1960 to 2000. What we saw during this era, the rise of electronics and computer technology. The third industrial revolution, beginning in 1960s, was marked by widespread adoption of electronics and computer technology. Innovation such as microprocessor and personal computer transformed industries by enabling automation and enhancing data processing capabilities. Automation and robotics. Automation became a defining characteristics of third industrial revolution with the introduction of programmable logical controllers, that is called PLCs, and industrial robots in manufacturing. These technologies streamline production lines, reduce labor costs, and increase precision in tasks like assembly and quality control. The impact of automation not only boosted the productivity but also changed the labor landscape, leading to demand for skilled workers who could operate and maintain this advanced system. Now we are moving into era wherein we could really see from an era where even unskilled labor or women or children were used to an era wherein we specially required skilled people to manage because we are driven by highly skilled technology. So rise of electronics and computer technology, if I have to say, it is driven by advancement in electronics and computers, apparently, which transform the industry by making processor faster, most efficient, and most automated. So key innovations during period included the microprocessor and the rise of personal computers. What is microprocessor? Microprocessor is a small chip that contains the entire central processing system, that is called CPU, of a computer. Is It made computer much smaller, cheaper, and more powerful before the microprocessor computer were massive. We have all seen the transformation of computers when it started from desktop to a laptop to tab today. We have seen how from a size wherein we needed a bigger table, now it can be managed on a lap as well. So that is the transformation we have seen. The microprocessor allowed computers to be used in home and business, making technology more accessible. If I have to cite an example, the development of Intel 4004 microprocessor in 1971 is one of the milestones of the third industrial revolution. It was the first commercially available microprocessor and revolutionized computing. It led to the foundation for personal computers, which eventually become widespread in offices and home as well. Personal computers, with advancement in microprocessor technology, computers become very affordable and practical for personal and business uses. PCs allowed for better data processing, record keeping, and automation of various business tasks. So when we joined an organization, it was only somebody at a higher level who was given a desktop, or he was the one who would have been recognized by the fact that yes, he's using a computer, so he's a senior guy. But over a period of time, with the microprocessor getting cheaper, it became affordable, and then it from the necessities, from the utility, it became necessity. It has from the commercial places, it moved to everybody's house. So if I have to talk about example, Apple introduction of Apple II in 1977 and IBM PC in 1981 made personal computer mainstream business. So now every organization could use computer for tasks like word processing, accounting, and inventory management, revolutionizing office work and creating new industry focused on software development, automation, and robotics. One of the most transformative aspect of the third industrial revolution was introduction of automation in manufacturing. This was made possible through technologies like programmable logical control, that is PLCs, and industrial robotics. These innovations allowed machines to take over as many as manual tasks that were previously done by human workers, making production faster, more precise, and in a more cost effective manner. So, what is programmable logical controllers? They are digital computers used to control machinery in industrial processes. They allow factories to automate complex sequence of tasks such as assembling parts, packaging product, or controlling conveyor belts. So the advantage of PLCs are that they can be reprogrammed to handle different tasks, making production more flexible. So for example, if I have to cite, in an automotive industries, PLCs are used to control the assembly line, ensuring that each car part is assembled correctly and efficiently. For an example, General Motors was one of the first companies to implement PLCs in their production process, which increased the speed and accuracy of the car manufacturing. Industrial robots. Industrial robots are programmable machines capable of performing complex tasks like assembly welding, painting, and material handling. They work with high precision, making production faster and improving the quality of goods. Robots replace many repetitive manual tasks and also allowed factories to operate 24 by 7 without needing breaks or rest. For example, KUKA robots in the automotive industries have become famous for assembling car parts with incredible precision. In car manufacturing, industrial robots can assemble and weld body parts, applying paint, and even inspect the quality of the work with minimal human intervention. So this technology is used by companies like Tesla in its electrical vehicle production. Impact of labor. If I have to give an explanation, I would like to say that while automation and robotics improved productivity and efficiency, they also had significant impact on labor force. Many jobs that evolved repetitive manual tasks were replaced by machines, reducing the demand for unskilled labor. However, it is very important to note that shift created a new demand for skilled workers who could operate, maintain, and program these advanced systems. That is very important to understand that technology is never a threat, it is a boon. And while it may eliminate fewer jobs, it could create significant number of newer jobs, making a person more skilled and more accurate by adapting the newer way of technology. So, however, this shift created a new demand. As I said, we could who could operate, maintain, and program in an advanced and a systematic way, which led to a transformation in the labor market, which focused on technical and engineering skills. So, if I have to cite an example, in manufacturing, job like manual assembly line workers just decreased drastically, because robots took over these roles. And then they were so perfect in their role that it eliminated the need of human intervention. There where the work was so precisionized that human intervention was not required. At the same time, the demand of robotic engineers, technicians, and software program increased. It is not that, while the role of an unskilled worker decreased, the required of manpower also eliminated. It's not that way. So at one hand we see the reduction in the role of a manpower, whereas in other area we see the enhancement of a role wherein we require engineers, technicians, and software programmers, wherein now people are mandatorily required to upskill themselves to ensure that they are part of this community, they are part of this market, they are part of this economy. Increased workers had adapted, acquiring new skill in operating and maintaining this automated system, leading to the rise of specialized training program and technical education. So, if you see, the third revolution was marked by the rise of electronics and computers, which revolutionized how industries operated. The development of microprocessor enabled the creation of smaller chips and more powerful computers which transport office work and industrial processes drastically. Automation through PLCs and industrial robots allowed factories to automate repetitive tasks, making production more efficient, faster, and less dependent on human labor. The technological shift also transformed the labor market, reducing the need for unskilled workers, but at the same time, increasing the demand for those with technical skill to manage and maintain the automated system. The advancement in automation and electronics from this period led to the groundwork for Industry 4, which integrates the digital technologies, AI, and data analytics into manufacturing. Hope I am clear till now, students.
Absolutely, sir.
Okay.
I can see that there is, as of now, no queries raised, but
Okay.
you're very much understandable.
Now coming to the fourth industrial revolution, that is Industry 4. This is what we talk the revolution as of today, because the revolution won't end here. We will see Industry 4, Industry 5, Industry 6 coming. But now, as of now, we are standing on Industry 4. So if I have to explain Industry 4, I will start with, integration of cyber physical systems. So definition of cyber physical system, that is CPS, refers to the combination of physical process and computational elements in the context of Industry 4. CPS enables machine and system to communicate with each other and with humans in real time, creating a network environment. So example, smart sensors embedded in manufacturing equipment can monitor performance and predict maintenance needs, which can reduce downtime. For instance, a manufacturing plant might utilize CPS to enable machines to adjust their operational based on real-time data analytics, improving efficiency and reducing wastage. The interconnectedness allows for a more responsive and adaptive manufacturing process where changes can be implemented and swiftly made to the customer's demand. enhance data analytics and decision making. So definition, if I have to say, Industry 4 leverages advanced data analytics, including big data and machine learning, to transfer raw data into actionable insight. This enhances decision-making processes at all level of manufacturing. So today we are at the era wherein, we have got lot of elements to give us avenue to decide, and big data is all about, using it for a effective and precision decision making. 'Cause at the end of the day, technology plays a very wider role in collaborating with human, and giving a very substantial feedback wherein we have to understand, interpret and implement. And that is why, the result is so precious that it not only eliminates wastages, but it also ensures that, any kind of downtime or unpredictiveness or, uncertainties are eliminated. So if you see the impact, manufacturers can analyze data collected from various sources like production line, supply chain, customer feedback to identify the trend, optimize operations and focus demand. For example, predictive analytics can foresee equipment's failure before they occur, allowing for proactive maintenance and minimizing disruptions. So this data-driven approach not only enhances the operational efficiency, but also fosters innovation by enabling companies to quickly adapt to market changes and consumer preferences. So you are working 24 by 7. You have a machinery 24 by 7. The market is highly competitive. There is a very cutthroat demand as well as supply. And the moment you fail in your supply in time, you are going to face a very substantial hit in the market. So what this technology does, they gives you a very proactive alert in case of any issues that can pop up out of this machinery, so that you can proactively ensure that you eliminate and you do corrective measures to those machinery, so that the production is not impacted. So specifically, if I have to talk about Industry 4 or the fourth industrial revolution, it works by integrating advanced digital technologies into traditional manufacturing and industry process. And the core idea is to create smart factories where machine systems and humans communicate and collaborate in real time through the use of data, automation, and connectivity. So if I have to break this down into various functions, so first thing is, core technology which is going to be used or which are in used in Industry 4, they are as under Internet of Things. This involves embedded sensors and connectivity into physical objects, that is machines, vehicle, etc., to collect and exchange data. For example, in a factory, machine can communicate with each other, adjusting operations automatically to increase efficiency. Artificial intelligence and machine learning. So these technologies analyze the data gathered by IoT devices to make predictive decisions. While IoT plays its role, the next level of job is played by artificial intelligence and machine learning. And AI can help optimize production schedules, predict maintenance needs, and improve quality control. Third comes big data and analytics. Larger volumes of data are generated by sensors, machines, and systems. So big data analytics largely processes this information to find patterns, make predictions, and enhance decision making. Robotics and automation. So Industry 4 also emphasize using robots to automate repetitive and complex tasks. So you will not be surprised that in few years from now, in an organization, you will have few of your team members who are human. At the same time, few of your team members are robots. So you will have a reporting of human as well as robots. So they are going to be a part of your core team. That is the future. So robotics and automation plays key role in smart factories, and they work alongside human workers, performing tasks like assembly, welding, or material handling with high precision and speed. Cloud computing. So cloud-based systems stores and processes vast amounts of data remotely, which gives industry access to data and computing power from anywhere. This allows flexibility, scalability, as well as cost savings. Cyber physical system, that is also called CPS in a short term, are systems where physical machinery is linked to digital network, creating a bridge in digital and physical work. CPS enables machines to self-monitor and self-optimize based on real-time data. So how this system works, in automotive industry assembly plant, a sensor of a machine monitor their performance and send the real-time data about any fault or inefficiency to central system. If a machine is about to break down, the system alerts operators to schedule a preventive maintenance by, whereby reducing the downtime. Automation of smart machine, wherein robot, AI, and PLCs plays critical role, which automate the tasks were traditionally performed by humans. So these technologies can work continuously, performing repetitive tasks like welding and etc. So smart factories can also automatically adjust production lines based on data inputs such as customer orders, ensuring just in time. Example, if I have to cite Siemens Hamburg plant in Germany is fully automated smart factory where 75% of their production process is handled by machines while humans only oversee and maintain the system. Machines equipped with sensors constantly collect operational data such as temperature, pressures, and vibration. And this data is sent to cloud servers where advanced algorithms analyze it to detect patterns. Predictive maintenance is very key feature of Industry 4, where AI uses data to predict when the machine is likely to fail or need maintenance. And this helps avoid unplanned downtime and extend the lifespan and the equipment. So if I have to cite an example, General Electric uses predictive maintenance in its wind turbine. So sensor tracks the turbine's performance and AI predicts maintenance needs, reducing the operational cost and improving the efficiency and eliminating the downtime. So customization and flexibility, Industry 4 allows mass customization, meaning factories can adjust their production line to manufacturing personalized products without sacrificing any efficiency. Flexible production system can quickly switch between product types based on the customer's demand and thanks to smart machineries and real-time data. Adidas uses robotic manufacturing system to produce customized shoes. This speed factory can adjust production parameter automatically based on the customer's order, producing the personalized footwear at scale. Digital twin is a virtual replica of physical asset or that mirrors its real-time operation by stimulating production scenario and machinery behavior. Companies can identify uh, inefficiencies or potential failure before they occur. So for an example, if I have to cite in an aerospace company like Rolls-Royce, which use digital twin to monitor and predict their performance of aircraft engines in real time, optimizing performance and maintenance schedule. So smart production leverages interconnected machines, automation, and AI to optimize the entire manufacturing process from raw material to finished good. And Volkswagen is one of the example which uses thousands of AI-powered robots and connected devices to automate and streamline production to its factory. So the with enhanced supply chain, Industry 4.2 integrates real-time tracking and data sharing across supply chain. Companies can monitor their inventory level, track shipments, and predict supply chain disruption, making the process more efficient and resilient. If I have to cite an example, Walmart uses blockchain to track the provenance of food products, ensuring that every stage of supply chain is visible and transparent. This ensures that product quality and safety is maintained. Automated quality control system uses AI and machine vision to inspect product for defects in real time, allowing for more accurate and consistent inspection. Example, BMW uses AI-driven cameras in its own factory to inspect vehicles during assembly.
Very good evening, sir.
Yeah.
We are on the same slide from the last 10 minutes, sir. Enhanced analytics and decision making.
Okay. So no, I have been giving my speech. Basically, I covered everything on through my speech. Basically, I kept the slide idle, but I covered most of the points.
No issue, sir. The slide will basically help us to see your point or context.
No, I will share this presentation also if needed, and students can go through.
Please, sir. Please, sir. Please, sir. Okay.
Yeah. So if I have to relate on case studies, a successful implementation of Industry 4, Siemens Smart Factory in Hamburg, which I have already stated, and Bosch Connected Manufacturing. Bosch embraced Industry 4 by integrating connected system in its manufacturing plant, focusing on automotive plants. So key features here were smart sensors and analytics. Bosch uses smart sensor to gather data throughout the manufacturing process, enabling real-time adjustment and quality control. So outcome, the result has been significant reduction in defects and waste, as well as enhanced flexibility to respond to customer demand, leading to more efficient and sustainable operation. I will talk about something not mentioned in my slide, that is cloud computing and IoT, which enables companies to monitor and control manufacturing operations remotely. Manager can access production data on from a remote basis and adjust parameters from anywhere, reducing the need for on-site supervisor. And an example, great example to this is Schneider Electrics, which provides industrial IoT solution that allows factory to remotely monitor and control energy usage, machinery performance, and environmental condition, optimizing operations in real time. So impact of Industry 4, what could be derived, finally, it is efficiency and flexibility. Smart factories can adjust to the changes in demand, improving efficiency and reducing waste. Cost saving, definitely. Automation and predictive maintenance reduces labor cost, downtime, and material wastages. Sustainability, which is the key demand of now, data driven optimization leads to lower energy consumption and more sustainable practice. Workflow changes, while repetitive jobs may decline, there is a growing demand for skilled workers who can manage and maintain advanced technologies like AI and robotics. So precisely, Industry 4 operates through seamless integration of smart technology, automation, data analytics, and connectivity, transforming the traditional manufacturing into high efficient, flexible, and data driven system. It definitely optimizes processes, enhances quality control, and enable mass communication customization, paving the way for future industrial revolution like Industry 5, which will further emphasize human machine collaboration and sustainability. So the challenges and risk for Industry 4, cyber security threats, vulnerability of connected system. With the increased connectivity through IoT, while we discuss these, the benefits of Industry 4, there are certain challenges which we still need to mitigate, and which are increased connectivity to IoT device and cloud-based platform. Manufacturers are more exposed to cyber attacks. A breach could be led to theft of sensitive data, production downtime, or even safety incident. So mitigation strategies, company must invest in robust cyber security measures, including firewalls, encryption, and employee training in security best practices. Regular audits and updates to security protocols are very much essential to safeguard against the evolving threats. The need for new skill tests. The shift towards automation, AI, and data analytics requires a workflow skilled in this advanced technology. Many employees may lack the necessary training, leading to a talent shortage. Integration and compatibility issues. The complexity of legacy system. Many manufacturing companies operate with the legacy system that they may not easily integrate with the new Industry 4 technologies. This can lead to compatibility issues and hinder the transition to a smart manufacturing. Strategic planning, a well-defined digital transformation strategy is very much important. Organizations should access their existing system, identify integration challenges, and consider phase-wise implementation to minimize disruption while adopting new technologies. Future trend in manufacturing industry. For enhanced automation, AI will play a crucial role in automating complex tasks that were previously difficult for machines, from predictive maintenance to quality control. Algorithms will analyze data and make real-time adjustments, significantly improving operational efficiency. Smart decision making. AI will facilitate smarter decision making by providing insights derived from vast amounts of data and greater focus on sustainability. Eco-friendly practices. As environmental concerns grow, manufacturers will increasingly adopt sustainable practices such as using renewable energy sources and minimizing waste. Industry 4 technologies can help monitor and optimize the resource consumption, leading to a greener operation. Circular economy. The concept of circular economy, which emphasizes recycling and reusing material, will gain traction. Advanced manufacturing technologies will enable more efficient resource recovery and product life cycle management, fostering a more sustainable approach to the production. Customization and personalization at scale. So mass customization, advances in technology like 3D printing and flexible manufacturing systems will allow companies to offer customized production at scale. So is Industry 4 here to stay? Yes, the technology advancement, the rapid pace of innovation in AI, machine learning, robotics, and IoT means this technology will continue to evolve, driving even more integration and automation. Economy competitiveness. To remain competitive globally, companies are investing heavily in the Industry 4 technologies. Business that fail to adapt risk falling behind as they cannot match the speed, efficiency, or quality of Industry 4 enabled enterprises. As I spoke, sustainability and resilience will play important role. And the COVID-19 pandemic highlighted the need for more automated, flexible, and digitally connected industries. Companies that had already embraced Industry 4 were able to adapt more quickly mitigation the impact on operations. And the next step is Industry 5. While Industry 4 focuses on automation and connectivity, Industry 5 is expected to bring human touch back into picture. The next phase will be emphasize collaboration between humans and machine, where human creativity and strategic thinking are enhanced by AI and robotics. Personalized and AI enhanced decision making will become more prevalent, leading to a new wave of innovation in industries like healthcare, manufacturing, and logistics. Sustainability definitely will be at core of Industry 5 as business seek to build sustainable production process with focus on human welfare and environmental responsibility. So impact on employment, shift in job demand. Automation and robotics will definitely reduce the demand for low skill and repetitive task jobs that involve manual assembly, inspection, and data entry are likely to be replaced by machine. However, it is very important to note that there will be increased demand for highly skilled workers who can operate and maintain advanced systems. So what will be required? Reskilling and upskilling. Workers will require to acquire new skills such as data analysis, AI programming, and robotic maintenance to remain competitive in the job market. Government and industry are increasingly focusing on reskilling programs to help the workers adapt. For an example, in an automotive industry, many roles that once involved manual labor are now focused on programming robotics and managed automated process. So employee now need to train to handle this advanced system, creating in shift towards science, technology, engineering, and mathematics field. So new opportunities will exist. Despite concerns about job displacement, Industry 4 is expected to create new job opportunities. And definitely, in the field of data science, companies need professionals to analyze the vast amount of data generated by smart factories and IoT devices. So this will lead to a boom in demand for data scientists and AI specialists. So definitely there will be also change in the work environment. and the integration of AI and automation will also transform the work environment with a shift towards more flexible, remote, and hybrid working model. The jobs that evolve digital operation, data analysis, and monitoring can be performed remotely, offering workers more freedom in where and how they work. Example, the rise of smart factories allow certain tasks like machine monitoring and data analysis to be performed remotely, meaning employees can manage operations without being physically present at the facility. So, socialite impact, the rise of automation and AI can lead to job opportunities where the middle skill jobs decline and high skill and low skill jobs increases. Policymaker will need to address these challenges by ensuring access. So what is the conclusion? So recap of Industry 4 evolution. Industry 4 will represent the next phase in the evolution of manufacturing characteristic by the integration of digital technologies into traditional production process. The transformation will build upon the foundation laid by previous industrial revolution, leveraging advancement to create smarter, more efficient and responsive manufacturing system. To key benefit realized, the adoption of Industry 4 technology has led to significant improvement into productivity, efficiency, and quality. Companies are experiencing reduced operational costs through automation and real-time data insight, while also enhancing the ability to meet customers' demand with greater agility. Enhanced decision making driven by data analytics enable organizations to optimize their supply chain and production process, fostering a culture of continuous improvement. Challenges and path forward. However, the transition to Industry 4 is not without challenges. Cyber risk, cyber security risk, workflow skill gaps, and integration complexities presents significant hurdles that companies must address to fully realize the benefit of this technology. A strategic approach to digital transformation is essential. Companies should meet and invest in workflows development, strengthen cybersecurity measures, and ensure seamless integration of new technologies with existing systems. The importance of adaptability as we look, the future of adaptability will be the key. The manufacturing landscape is rapidly evolving, driven by technological advancement and enhancing the customer expectation. Organizations that remain agile and open to innovation will be the best position to try this dynamic environment. Embracing a culture of innovation and continuous learning will help the organization navigate the challenge and seize the opportunity presented by Industry 4. Final thought. In conclusion, Industry 4 is just not a technology shift. It represents a fundamental change in how manufacturing operates. By embracing this revolution, manufacturer can enhance this competitiveness, drive sustainable practice, and ultimately create value for customers and stakeholders alike. The future of manufacturing is bright, and with the right strategies and mindset, organization can lead the way into the new era. Thank you so much.
Thank you so much, sir. It was definitely enlightening experience, and such knowledge sharing and learning will definitely help us in the future. I am actually waiting for some of the queries. If any of the participant want to ask sir or want to get benefited by the experience of the sir, please don't be hesitant in asking your questions.
And also you can correct, yeah.
Yeah.
Good evening, sir. In case if you can pinpoint some case studies, you have given some references like Siemens case study, the Bosch adoption, Walmart. I have already gone through.
Yeah.
If you can, especially in the manufacturing side, if you can share some case studies.
I will share. If you can give me your email ID, I will mail you few of the case studies wherein I can give much more citation.
Sure, sir. You can share with the organizer, sir.
Yes.
We will get
So
it.
you can
Yeah.
share it with us, and with the help of
Yeah, yeah,
other
yeah.
PPTs as well,
That
we'll
will be
share
great.
that
Yeah,
along.
yeah.
Yeah, yeah, yeah.
It will be shared with everyone.
Yeah.
Whosoever is. Yeah.
I will share this PPT to the organizers, and I will add few more case studies to make it precise. I relied on few of the case studies, but I have few more case studies to be correlated. Then I will attach those to it, and I will share it with the organizer tomorrow.
Sure, sir. Sure. That will be great. Frankly speaking, when we quote these kind of things, half-cooked thing doesn't make any sense.
Correct.
So that's why I'm just requesting you if you can share those valuable
Yeah. I will share
material with
the
us. It
yeah.
will be a
Yes,
very,
yes, yes.
very
So
helpful.
this will correlate with the statement what I made apparently.
Yes.
Yeah, I will share it with the
Because
organizer.
some of the like manufacturing inclusion, robots inclusion, like Amazon, they are doing in their factories.
Yeah. They are doing
Maruti in India, they are already doing. Uh,
robotics are in used in masses, and we have seen. So
yes.
so I will give you example of how means it is not only on robotics, how AI, machine learning are also playing a critical role all across, and how
Yes.
supply chain has been availing this all across, and how post COVID many organizations have moved towards entire digitalization of their warehouses, and this entire end-to-end supply chain. That also I will share with you guys.
And if you can share some, besides case study, any technical paper write-ups on how these technologies are make into working, once you when you mentioned data collected in cloud and further analyzed
Yes.
with the AI to predict
Correct.
MRO services,
Correct.
machine repair services.
I will give you technical detail of that. I will
Please.
do that. I will
Yeah.
definitely.
Humble request, sir. Thank
No,
you.
no, no, no. Definitely, I will do that. I will do that.
We'll be sharing all the resources by the speakers after the sessions are over. At the end of the FDP, the participants who are interested may drop in an email their acceptance that they want to have the resources. We will definitely provide all the resources and whatever you require from the speaker. Uh, so there is one question, Abhijit sir,
Yeah.
in the chat box. Is mechanization bad for a country like India?
Yeah.
So they want to have your opinion on
No,
that.
no. What? I could not get it. Can you repeat that?
Mechanization, is it bad for a country like India, sir?
No, 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 not at all. See, it is not that we have seen mechanization is not happening in India. It is definitely happening, and if you see, India is so globally connected. There are a lot of things which have been exported from India. But only thing, is that we have to understand that technology is future, and what is available today will get absolute tomorrow. So each of us, including the crowd in the rural area, also need to upskill themselves, because at the end of the day the mechanization will lead and reach to each and every corner of the country. And definitely, to have the a better GDP rate, technology is one of the key function, wherein we have seen that the growing countries or the economy of those countries are specially working because of the technology. If you see an example, Sweden is one of the country which must be very small in size, has moved
Yes,
to
sir.
digitalization payment maybe decade ago. So although the implementation in India came much later, so it is not that digitalization is lethal or harmful. Digitalization is something which is going to improve your efficiency, make you lead to a qualitative output. So at the end of the day, technology is inevitable. You cannot avoid it. The organization which are skeptical at the end to remain in the competitive market, because we all are trying to compete the global market. We need to ensure to survive. We have to adapt technology, and over a period of time, through retrofitting and through transformation, we have to move toward mechanization. So it is bound to happen, and it is something which cannot be eliminated. And it is good for every nation, because at the end of the day, if the nation has to grow, technology plays a key important role for it.
I can see that many queries have now popped up in the chat box. I hope Omkar Nath sir is happy with
you
the
can you can mail
um
it to me, ma'am, because
yeah.
I have to get into a different meeting. So you can mail me
Yes,
all the queries.
for sure.
I, I will respond to all the questions along with the presentation, and apparently,
Yes,
I will add few
So,
more case studies to that.
so if you allow, I'll ask one more question which is connected.
Yeah.
Yeah, like is not India going too fast in mechanization? Is not like augmenting, because augmentation concept should be better, because the we are moving too fast and too many people are getting like unemployable. And should we not increase our like the engineers are not unemployable? So should we not also pay attention on the education part, where engineers should be more skill oriented rather than being oriented on the books?
No, but if you see now, what used to have prevailed a decade or a couple of decades ago, today, the system of education is much advanced. The institutes, the education system is much robust. But at the end of the day, when we started our career, there used to be hardly few institutes wherein the qualification was very much stringent to get qualified for being an engineer. So today the education system is much robust, and I don't think India is moving fast, because what I feel, if you have to survive the international market, we need to be at this page. And I also
Right,
feel,
sir. Sorry to disturb in between, sir. According to a recent survey, 90% of passed out engineers in India are not employable. They are only 10%. So that the problem has not been solved. We
no,
have
for
less doctors, but more engineers than we have actually need for engineers. So that's a very relevant thing in this particular present scenario, sir.
so which means we need to move much faster. We are not moving fast. We still need to move much faster to have more engineers in place. You will accommodate engineers only if you are moving faster. If you are not moving
Yes, sir.
with the,
We need to move fast, but we need to also keep a quality check on education, because that is what is happening. Because the engineering colleges which are propping up are not actually giving the kind of education which is required for an engineer.
no, that is true. There has to be a counter check on the quality, and at the same time, I think
Yes, sir. Yes,
the
sir.
more curriculum should come up, because today, if you see, if one has to understand AI or robotics or machine learning, it's very
Exactly, sir.
difficult.
Exactly.
It's
Dr.
very difficult.
Sarkar, can I, if you allow me, can I add few things?
Yes, definitely.
Government recently announced regarding the internship for engineers, those who are into college, already in the college, with the
Correct.
already established companies
Correct.
under the CSR scheme. I think government is already have taken the cognizant of that. Skill India is already under operation, I think, from last 7-8 years. So government of India is already onto that task, skilling in Indians for these kind of markets and these kind of industries.
No,
We
agree.
have,
Only thing is it needs to be expedited, because
yes.
industrialization is grooming fast, and definitely next 10 years we'll see a lot of rapid expansion. That's for sure.
And that's
Which,
why government of India put 2047 as a the milestone till that we must be a developed economy.
yes,
In
absolutely.
that process, the manufacturing industry has to come at par.
Yes, absolutely.
Yes,
Absolutely.
yes.
Absolutely. Absolutely. So, sir, thank you everyone, and it was really, nice sharing my views. I'm ready to answer, whatever question you receive, ma'am. You can share it to me.
yes.
I will share it
Sure,
with the
sir. We will
presentation.
definitely share. And thank you so much for the enlightening experience and the slides which you shared. Though we are getting a little bit late for our next session, but I think the audience actually enjoyed listening and, of course, gaining new knowledge. I will definitely be transferring these queries to you. And whenever we are sharing the resources, sir will, if sir has time and the time permits, sir will definitely try to solve all the queries.
Sure.
Thank you so much, Abhijit sir.
Thank you.
It
Thank
was a
you.
pleasure having you. Thank you so
Good
much.
evening, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Dear participants, as we move forward, um, our second session is aligned by Dr. Jigna Trivedi. Dr. Jigna is an alumnus of IIM Ahmedabad, where she has done her faculty development program. She holds a graduate and a postgraduate degree in management from Gujarat University, Ahmedabad. She holds a doctoral degree from SP University, Vallabh Vidyanagar, Anand. Ma'am is the Director in charge in Management Department at Sri Jairambai Patel Institute of Business Management and Computer Applications, formerly known as National Institute of Cooperative Management NICM Gandhinagar. She was also one of the in-charge director at NICM. She is a recognized guide of Gujarat Technical University and currently has 6 scholars pursuing the doctoral work under her guidance. She holds 1 year of corporate experience and 15 years of teaching experience. She has published 2 books titled New Paradigms of Business Plan for Select Horticultural Crops, a practical textbook for entrepreneurship and sugarcane growers and sugar cooperatives of Gujarat. Her expertise of knowledge is shared through visiting or guest assignments with various institutes of national importance such as EDI, PDPU, NIFT, IIPH, etc. She has also imparted research training to doctoral students and to farmers of FPOs and has also delivered sessions on value chain and business plan preparation at National Institute of Rural Development, Hyderabad. Her teaching areas consist of accounting for managers, cost accounting for managers, corporate taxation, mergers and acquisitions. She has actively contributed in organizing various co-curricular activities at state and national level business plan competition. Thank you so much, ma'am, for gracing your presence for our FDP. We look forward to our session with us.
Okay, anyways, we will start whenever it is proper. I mean, I can reshare it. Right now, it seems it is frozen. So, good evening, participants.
Very good evening, ma'am.
Okay.
Good evening, ma'am.
Yeah, good evening.
Good
Now to-
evening, ma'am.
Yes, good evening to everyone. Now, today we'll be starting with the guest session, and the topic which is given to me is overview of Industry 4.0 and its impact on manufacturing sector. So, any idea like if you are aware that what is exactly Industry 4.0? Any idea?
Kindly repeat the question.
I'm saying, are you aware about Industry 4.0? If anybody has any rough idea, then they can just share it with me.
May I, ma'am?
Just had a
Yes, please.
session, 1 hour session already. on
Okay.
this.
Now,
Yeah.
ma'am, if it is convenient for you, can you just put on your video so that at least you are being seen if the screen is not
Yes,
visible?
actually, the point is that the screen has frozen.
I
Just a
know.
second. I'm
The
not able to
technical
do
glitches
anything.
are a
I mean,
part of such online sessions.
just a
So,
minute, just.
yeah, ma'am, please.
May I, Dr. Trivedi?
Hello. हाँ ठीक है ऐसा
So
करते हैं यहाँ पर
I
तो
think
सब
Dr.
एकदम
Trivedi, this
frozen हो
is
गया
yeah, this is something remarkable. On the one side, we are talking about
Okay.
smart manufacturing, IoT. Am I audible?
Yes, Dr. Mamta, you are audible.
Yes, ma'am.
Thank you so much. So we have seen the first session also and the second session also. On one side, we are talking about smart manufacturing, remote controlling, that you can make the changes. On the other side, we have internet basic connectivity issue. So technically, we are talking about the machine learning and so many things related to mechanization to robotics. And when it comes to actually performing, are we really being very futuristic when we are talking about smart manufacturing? Actually, is it only a few companies or few manufacturing units following it? What is the future of production? First, let's talk about, or a review maybe. What exactly is happening? Is it only a few case studies we're talking about that these companies or these factories are how they are talking about automation? What is the level of automation when it comes to actual connectivity of internet? So your fiber opticals to Wi-Fi connectivity. So it puts a real question mark. I'm starting with the discussion because I'm utilizing the time. By the time ma'am is able to really maybe rejoin this session, that is one option that she can really avail. Dr. Trivedi may avail.
Yes, I will totally agree with Dr. Mamta that technical glitches do happen. And when we talk about robust technologies and Industry 4.0, let us also acknowledge the fact that the machines and the
Hello.
techniques involved will suffer from one or two lacunas, and the major challenge comes here
हाँ
only
हाँ
that how to
मैम मैं
overcome
कर ही रही हूँ बट प्रॉब्लम
so
ये है कि मेरा पूरा कंप्यूटर ही हैंग हो गया है जैसे ही मैंने जूम में लॉगिन किया एक मिनट आई
so
ट्राई इट वरना आई कैन टेक इट आप स्क्रीनशॉट ले लीजिए देन आई बी जस्ट टेकिंग हाँ हाँ हाँ
I think ma'am is figuring out some ways by which the issue can be solved.
So we may hold a discussion. Basically, we were continuing with the last discussion about
Yes,
employability of students and engineers. I think it's something being too optimistic when we are talking about having so many engineers, and then we are talking about the employability issue. Are we really having that skill set? Because everyone wants to go in a foreign country, have the dollar or some other currency. They don't want to work. I spoke to one of the students whose parents are into farming. He doesn't want to do farming. Everyone wants to be engineer. Everyone to have a AC room where they don't need to indulge into any. So this mental, I think, blockage you may say, or the mental, they're not thinking about what is requirement over there. Are we practical enough?
yes. So the forum is open for the discussion. What Dr. Mamta is trying to raise the issue is that is it really just about the upskilling, or is it really about the uh, things that they have to acknowledge the fact and the mental stability that may come, that it is not just about one country. If you are living in India, that what I have seen here is that nobody is as such very much happy with the domestic country, I would say. So if you're living in India, you want to go abroad. If you're in some another country, you want to leave that country and maybe settle somewhere else. Things remain the same. But yes, again, this might be my viewpoint. Others can also add in and, of course, join in this healthy discussion. Whether it is
Yeah.
just about upskilling, or is it also about a change in the mentality, or maybe change in the
Orientation about
yes, of
education,
course.
skilling.
Yes. Yes. It is not just about giving the education, but it is also about taking them to another level and thinking beyond the boundaries of just education. So, if
excuse
anybody
me
would like
ma'am
to add on. Yes, ma'am.
I will start. See, I've restarted my computer, but in the meantime, we can just initiate the discussion, right? So that
Yeah,
our
sure,
time
ma'am.
being saved. Okay.
Yeah, yeah.
So
Sure.
basically, as I was putting forward this question, that what is Industry 4.0? So, and why actually we need to study? Can anybody answer it out? Why we should know about this Industry 4.0?
May I, ma'am?
Would any participant? Yes, please.
Yeah, I think this is the theme of this FDP. So how the faculties needs to know what is happening in the industry, what is the current level, because we are talking about employability. So as a faculty, in case I am not aware what
Okay.
are the requirements for an industry to work
Hmm.
into, so what are the implications? So I'm the management, I would say, teacher. So for me, maybe I don't have the technical know-how about engineering, but how this industry functions so that I can orient my students to think about practically what they need to face. They'll not be talking about models, they'll not be talking about theories, but practically how they need to operate and what is the current level of technology they'll be employing.
Exactly.
So we may have
So,
something called nowadays we are using a lot of chatbots. We are using a lot of like ready-made solutions are there, but are they capable to check the solutions they are getting or the responses or the codes they are getting that is correct or not?
okay. So now, actually, see, my background is
Thank you,
also
ma'am.
management. Yeah.
All right.
So I'll be talking about this particular perspective about what I'll give the overview about what is happening in the industry as far as 4.0 is concerned, and somewhere we will try to see that how the things have changed. So technical background of engineering, etc., or artificial intelligence is also not our cup of tea as a management faculty. but then we should have a brief view about what is going on in the industry. So basically, the things that started is that if we look at India when we became independent, so there were 5-year plans that were framed, and their major thrust was on agriculture. So suddenly, agriculture, as we know, that many people are employed in that sector, but it doesn't contribute much to the GDP of the country. So, for the first time, we started talking about the second 5-year plan, in the second 5-year plan, which was in 1956 to 57, which lasted till 1960 to 61. Now, during that time, for the first time, we started giving priority to industries. And then we understood that all our industries are backbone and barometer for growth and development, because it will spin out many jobs, it provides products, services, right? It facilitates rather in providing services, and that is why all of a sudden we started giving importance to industries. Now, if we look at the real GDP in the year 2023, it was somewhere around 7.83. And in that GDP, industries contributed around 13% of GDP to India. Okay. Now, coming to the other part, if we see, there are industry revolutions that took place, and that was from 1.0 to 4.0, and 5.0 is the buzzword that is now going up, coming in, right? So, if we talk about Industry 1.0, what exactly happened in that? Any rough guesses? Industry 1.0, what was it? And where did it start?
It was like mass manufacturing, where like mostly the industry like manufacture of cloth manufacturing came into being, and once the speed was more, the raw materials required were more, and labor cost was less. That was, I think, was industrial revolution 1.0.
1.0. Okay. So, near to
Steam
the
engine, I
answer,
guess.
it was, pardon?
Electricity and steam engine, they also like came into
Yes. So
commercialization.
basically, yes. So in this particular revolution began in 1760s in England, and at that time there was introduction of water and steam, which was emphasized to transport the goods. So mechanization was the keyword for Industry 1.0. Whereas if you take the examples that came up in this industry was glass, mining, agriculture, and textiles, right? So here in the Industry 1.0, we were thinking that, okay, and mechanization. Then came up Industry 2.0. Now, there we started talking about mechanization, technology. So, the roots of 2.0 was in Britain, America, and Germany. And here specifically, we started talking about electrical technology. So there were machines that were emphasized, that were built, keeping into mind that they are user friendly and it is cost efficient, right? So the best examples for Industry 2.0 was automobiles and the planes that were manufactured. So slowly, this journey went ahead, and then came Industry 3.0. Now, this began in 1970s, where computer technology and IT was introduced. So, big computers, internet access, connectivity, renewable energy, all this started taking place. So, here in Industry 3.0, it was more of manufacturing and automation. I hope the Industry 1.0, 2.0, and 3.0 transitions are clear. Everybody? Yes, all of you?
Yes, ma'am.
Okay.
Yes, ma'am.
Then came Yes, then it was very difficult to say that from which year this industry 4.0 started, right? So for the first time somewhere in 2011, this word was coined, industry 4.0, and it talked about smart machines, storage system, production facilities, etc. IoT was the buzzword, and we also not only talked about industry, but we also started taking care of the environment. So sustainability, green technology, all these things were emphasized in industry 4.0. So it largely addressed three things: industry 4.0, environmental, economic, and social. And today almost we can say that all sectors that are there are in this phase of 4.0. Now, in 5.0, it is like artificial intelligence, robots. It is visualized that
Digna ma'am,
5.0.
it will be very much comfortable for the participants if you could show us the slides now, if you could try again.
Say, madam, I have restarted and I am in the process of mailing it to Sarmishta, madam. So just give me little time.
Can you not share it from your PC or laptop you are having?
Wait, let me try. If it happens, because moment I try to share and it is not working. Just a minute, let me try. Or else madam can share from that side.
It becomes easier for us to have
I know I have
visual
prepared,
communication.
but
Yes, of
then
course.
this is the okay. Sarmishta madam, I have shared with you if you can share it on the screen.
Have you shared it with Sarmishta ma'am?
Yes, I have emailed her.
Ma'am, you may proceed, please. It's okay.
Okay, so here in industry 5.0, it is visualized that artificial intelligence and robots, that is, and humans will be working side by side. And the objective of 5.0 would be to improve efficiency, automation, and customization. Now, as I will move forward, it is like first we will understand the keywords over here, and then we will be talking about little case studies. So, machine learning, if you try to understand, so what exactly comes to your mind when I say machine learning? What is machine learning basically?
Machine learning is like what I understand is machines will
Hmm.
learn from humans how to do things specifically, and
Hmm.
over a period of time, since they have more processing capacity, so they'll be
Hmm.
better than us in thinking and improving the processes.
Hmm. So they will learn from human, as rightly said, and they will develop those competencies to learn from their experiences. So it is again, ML is a subset of, I would say, artificial intelligence, because machine will learn from the past experience and they will then further make a constructive future decisions. So it is all done autonomously and it allows computer to learn from the previous data. And the best examples that we are using in our daily lives, if you look at these spam mails which are there in the folder, so there Google is using machine learning to filter the spam messages so that our mailbox does not get flooded, right? Similarly, other example could be like Siri and Alexa, which are virtual assistants, and they recognize the voice and they, offer tailored help. So, any other example that one can share of machine learning?
Ma'am, I
Machine
think
learning.
when we use an
Mm-hmm.
application like Spotify,
Mm-hmm.
and we tend to listen to certain category of songs. So, when next time we again go to Spotify, then again it gives us a similar kind of song suggestions. I think that is
Exactly.
also part of
Of machine
machine
learning.
learning.
Yes, yes.
Yes.
Mm-hmm. So, the purpose
And
of
number of times
machine,
on online
yes.
these online outlets also, because of
Mm-hmm.
repetition. So they can check the person's past search behavior. And based upon that, they give recommendation and they link it also. One is they learn from humans. Second, it's a repetitive. In case 20 times I term apple as orange. So they don't have their own mind. So because of repetition, that pattern, they'll accept
Yes.
this just look like an apple is actually the orange. So that is the concept of this machine learning, that what we repeat and keep on feeding them, they'll accept it. It's something
True.
majority effect. If all of us raise a hand on some way that yes, all of us yes, so machine will accept because majority is saying the same. So when two things get associated, they linked it also. And along with this thing, because pattern says most of the people going for oats are going for jaggery also. So they
True.
link it also. That is a second level of application. Repetition, human behavior, repeating, then finding the pattern, then giving the same response. They create those kind of algos. This is my
Ma'am,
idea.
let
Yes.
me put a technical context to this.
Uh-huh.
Machine learning is largely described under two division, supervised learning and unsupervised learning. Where supervised learning, what you are telling is rule-based, where we are defining is a kind of classifying the object. Like if you are saying oranges as a oranges, but if you label as a tomato, it will recognize orange as a tomato depending on the rule. The rule, whatever you're defining, the label that you define. We call it supervised learning. The second part is again classification, the different algorithms, whereby uh, uh, they keep on getting these data and then labeling them as oranges or tomato, and at a point once they are trained enough with enough data, they are able to recognize the new entry as it comes. So in network trafficking, we are using these kind of algorithms to identify the spam or whether this user is hostile to our system or not. We can use that. So the otherwise, then the further algorithms comes in within under these two large category with classification and so on.
Okay, fine. So,
Ma'am, one
Sarveshwar,
thing I will add here.
yes.
Ma'am, just now that Apple has launched iOS 18,
Hmm.
and the user, those who are using previous version of Apple in iPad, so what actually does it when you will sleep, that time only if Wi-Fi is on, that update will be automatically update. Whenever you are waking up, that time it will not have the update automatically. So how this pattern they have recognized by seeing that during night time generally people watch something or at time what you, so that pattern Apple recognize on their database, and finally they will give the update when you will sleep unless you force to update you to Apple 18. This is a magical thing, rather I can say.
No,
Many other
it's not a
updates.
magical. It's again based on your pattern.
Pattern,
Yes,
yes.
yes,
It's
yes. That's the
recognize
thing.
these kind of thing as a learning, as a rule.
Yes, yes.
Yes, and there's no
So
activity on the phone means you're in sleeping mode. So that's
generally, other updates, whenever you fix the time, that time your computer Windows update it will do.
the
But
moment
Apple
you
has
fix
gone
it.
beyond it.
The moment you fix it is a rule.
Ah, yes, that's I am just clarifying it that
Yes,
you have told that rule based and
everything,
not.
whatever example you bring in, come down to that definition only.
Yes, yes.
Ma'am, can you see the screen now?
Yes.
Yes, we can see the screen. Okay, you can take the next slide.
Okay.
Okay, this I have already talked about. Yes. So this was. Please change the slide. We are on the key terms. Please change the slide. Yes. This has been done. Yes, next. Yes. Further. Okay. Next. Okay, so machine learning we have already discussed. So the basic purpose of machine learning, can you take the next slide, please? It is all about making our daily task easy. And as many examples have been given by participants, so we are not going into much detail. So now by far and large, we have understood that it recognizes the pattern, and then eventually that pattern is being used further for making our task easy. Next slide, please. Now going for the next key term, that is artificial intelligence. So here again, it is the ability of machines, like how they perform the task, which need the intelligence which are showcased by the human. So here it includes machine learning via deep learning. So deep learning is where machines absorb the huge amount of unstructured data like text, images, audio, etc. And the machines will automatically learn from the existing data without any humans being taking any say in the process. So if we take the example of Amazon's assistant Alexa, so here the how it is predicting to internet predicting what we may like to buy the next. So based on a pattern, it would just decide that, okay, this could be like, let's say if I have searched for some smartwatch, so next time the new thing comes up and it will be like showing me that offer. So self-driving cars are again example of AI. Chatbot is again an example of artificial intelligence. The call centers, earlier we had this person answering our queries at the call centers, but now it is all based on the chatbots, and maybe with the use of artificial intelligence, we have removed the use of the human beings over here. Next. Then comes augmented reality, another key term where we try to see it adds to the reality that you are actually ordinarily seeing. So, for example, Vito's Technology Star Walk app. Now, what this app is doing, that if you point the phone or tablet camera to the sky, then it will give the names of the planets and constellations superimposed on the image. Then another one is plant snap. This is where, again, if you point the camera on the plant, then it will give the details of leaves, flowers, and certain name of the species. Another one, the Pokemon, that is again a very popular game where they talk about the characters that are around their environment. And the goal is like to capture these pocket monsters and then use them to battle others. So these are a kind of augmented reality that are being used by the marketeers to attract the customers, right? So if can anybody share the example, if participants would like to share a few examples. Yes, one from my side is like ICA is using it, where you can just use augmented reality and try to see that which furniture will fix in which particular corner of the house, right? Even this augmented reality are used a lot in the healthcare sector, where let's say and even students in education sector, especially in labs, they are using it for simulation, or microscopic objects are then referred in 3D or things like that, where the visual becomes more appealing. Okay, I want some examples from the participant side.
Yes, ma'am. Just like Google Lens is an example of augmented reality where you point it at anything or any picture. It gives you some results. It's not filtered, it's not exact right now, but it's developing slowly. So Google Lens in the future, if you point at a fan, it can tell you the brand and at what speed it goes. So that's an example of augmented reality which we can experience. Everybody can do.
Definitely. Okay.
Ma'am, lens card, in case we are trying to wear, how it would look like. Would it be same application like what you're telling us?
Yes, a kind of
I can try virtually.
The trial rooms that are there, that would be virtual reality will try to interact with the computer generated environment in real time. So augmented
That means it's
reality.
augmented reality.
Augmented would be like the object is in front of you, that is the reality, and you are trying to get something out of it. In virtual, what happens is the object is not in reality. See, I am taking it in the next slide. Please, if we can move to the lens cart, yeah, giving examples of that is virtual reality. So it's a technology that allows users to interact with computer generated environment in real time. So if you take the example of Volvo, it uses virtual reality where, let's say, one goes for a test drive and using their phone and experience that is weekend escape via an app. So here the virtual reality's driver is put on the seat. I mean, driver is not real, but a test drive can be taken by just putting the virtual reality into play. And then it is like through this test drive, one can see that how the car is moving, right, on the hilly roads, etc. So this enables users to go on a virtual adventure, and it is more of a immersive experience. Similarly,
So,
this,
ma'am,
yeah.
I'm sorry to interrupt. Simulation is different from this virtual reality.
Simulation, I guess it would be, it helps in that experience part only. So according to me, it would be in virtual reality only. This is what I feel, because see, the virtual reality is talking about the experience that one gets through the computer generated environment, and augmented reality talks about the object is there in front of you, and then you are trying to find more details about it, right? Can we go to the next slide, please? Okay. Another example, if we take about virtual reality, it's L'Oreal, which is having different makeups. They try to let the customers play with different makeup looks through its Makeup Genius app. And this is the users can virtually try on makeup and explore the curated looks. So here they need not go personally and just try out, but based on their face cut, they can see that okay, which makeup suits their particular face cut. So this app is accessible on both mobile and desktop devices, and here even the usage of this virtual realities to such an extent that the recommendations and alerts are also received to the people who are loyal to this L'Oreal products who keep buying. Similarly, the virtual reality, as I was talking about this furniture company IQAC, right? So they're using 3D models. One can fix out that, okay, in which corner, which particular furniture and fixture would be feasible. So it uses, the app uses various this kind of camera first experiences, and this would help in finding out like which particular furniture is suitable for which particular room, or maybe maybe a residential or a commercial property if we are looking forward. Next one. Then comes a mixed reality. So it's a blend of digital elements and the real world counterparts in such a way that the users to interact with the digital elements. And here you need to have the MR headset or smartphone camera to experience this mixed reality. Can you go to the next slide? Here I have tried to explain that, okay, these are the three things, that is virtual, augmented, and mixed reality. Can we go to the next slide, please? Okay. So if you take, for example, as we have understood the augmented reality, let us look at the example given. The restaurants will, using augmented reality, they will be able to give the diners the option of like viewing the menu items using the AR technology, even specifications like what could be the size of the order, how much customer satisfaction would be derived by giving more details about the food to the customer. And it would save the restaurants money because they need not go for the physical printing of this menu. So here the augmented reality can be used. Virtual reality, as it is 3D computer simulated aspects, digital, where the users can interact with digital objects. You only thing is by either clicking mouse or using some wearable devices, etc. Whereas if we take about the mixed reality, then it's a augmented reality, and here the users, it allows the users to manipulate and interact with virtual objects. So for example, the retail merchandisers, they can use mixed reality, which will help them to visualize a store layout before carrying it out in the real world. So this is where they can say that, okay, if we want to place the racks, then what should be the layout of the store, whether it should be in semicircle layout or it should be a line layout, etc. Right? So a hologram can also display how it will look to it. So your example could be a promotional display at the front of the store. For that matter, let's say if a student has taken some course on this what we say museum related thing, they are learning about how to manage the museum. So the skills of working in a museum, they can do it on the artifact, etc., through mixed reality without actually potentially damaging the valuable items. Again, if you look at it in the beauty parlor segments, right, where the learner is asked to learn, for example, the hair cutting. So there again, the mixed reality can be used where without actually cutting somebody's hair, the proper type of different varieties of hair cutting can be learned by the learners, right? So I hope these three things are clear: augmented, virtual, and mixed reality. Shall we move ahead? Okay. Any examples that participants would like to share under mixed reality? Any examples?
In the healthcare sector, it is been widely used nowadays while diagnosing
Your
the
voice, sir, your voice is not properly audible.
hello. Now it is
Yes.
clear.
Yes, yes.
In hospital and healthcare sector nowadays, they are using this technology for diagnosing the diseases with the comparing uh, models of different healthcare sector, the complications and the symptoms. The doctors it is rather, I can say, assistive technology. So XR, extended reality, that is actually they are now it is calling the virtual, augmented, and mixed, and now they are going to extended reality, XR.
Extended.
Then this diagnosing the diseases and the symptoms, the patients, rather I can say, in the psychological effects, many cases where the pupil movement, the which is very difficult to judge by the person, a doctor, by seeing only the expressions, especially in neuro disorders.
Okay.
So this is used.
This is used, exactly. So any other example from augmented reality or virtual reality? Any participants would like to give?
Ma'am, I'm not sure, but what about 3D printers?
3D printers. So can you just elaborate on that?
Ma'am, 3D printers, like they give you a 3D model of anything. It's not a proper page printout, but it's a an object is printed out in a three-dimensional form. So, but I'm not sure which category it falls into, augmented or virtual. Of course, it's not virtual. You get the figure out of the printer. So,
So
I'm
figure
also not
is,
sure.
yes, would anybody?
I could explain that. I could
Yes.
explain that. Earlier, we used to, like in biology classes, we used to take a physical frog and then dissect it. Right. Now we have the 3D print of the frog. We don't need to kill the frog, and we can have a 3D printout on a 3D printer, and then we can do the same act without actually killing the and removing the life from the frog. Frog can go free, and you can have thousands of models where you can do the same thing and learn the same thing.
So where we should place it? Mixed reality or
This we
augmented
call it,
reality?
ma'am, additive manufacturing. This is part of in Industrial Revolution 5.0. It has nothing to do with these concepts.
Nothing
Sorry
to
to
do.
say.
Okay, okay.
No,
Yeah.
thank you for the information, sir. Thank you.
So another thing that we would like to understand is metaverse. This is also one of the word which has been coined under Industry 4.0. So here it is 3D enabled digital space which uses virtual reality, augmented reality, your advanced internet and semiconductor technology. And this will help the people to have life-like personal and business experience. And the best examples are the Sandbox, which is a virtual metaverse. And there the users will actually build the virtual world where they can buy the assets, sell the assets. And for buying and selling of those assets, they use these non-fungible tokens, right? So NFTs, we call it as. And these are digital certificates of the ownership and authenticity of the assets that are there. So this is also one of the aspect where we say that metaverse, when this Bitcoin, etc., was introduced, right? So this was at the back end, these things were working as far as the revolution was concerned. Next. Okay, then another one which is very popular, that is robotics, where the with versatility in the mind, a robot can perform different types of tasks and it can even adapt to the changing environment. So there are many, like creating robots for daily use. So autonomous mobile robots, where they are being often used in warehouses for order fulfillment purpose. Then in daily life, like social family robots, cleaning robots, cooking aids, right? These are the robots which would help in, let's say, there are robot maps and vacuums which will clean the floor or clean the carpet. Automated kitchens where the robots are acting as a chef, and fully robotic kitchens are becoming available. So this is again the use of technology for the purpose of easing the human life. Next. Okay. Now there are a couple of case studies that I have found where how the industries have used it. So if we take the case of Hyundai, so it has used IoT, artificial intelligence, machine learning, and virtual reality. So here, by using this type of industrial revolution, what happened was it could reduce its maintenance time by 5%. Quality checks happened very quickly and processes were improved. Any damages of any goods, etc., if there are there, then it was just like the rate of damage reduced to 1%, right? And the tangible results that we can see out of using this technology was the series of the different types of models that Hyundai came up with. So it is like they have in their company, smart employees power the smart factory. So where they try to emphasize that, okay, the employees are also innovative, they think differently, and they help the company in building the new models, and by, of course, using this AI, ML, and VR. Okay, next. Another what happened by deploying this artificial intelligence and VR, etc. So they digitally connected shops and generated around 12 billion data points. Now these data points were analyzed, and with the use of AI and ML, all the data points were used to make data-driven decisions. So, for example, in the assembly shop, where all engine, suspension, electrical, and underbody parts were fitted into the car, and there was a complete testing that was done in the assembly shop, which ensured that there was zero defects, right? Earlier, the status was like they had to remember all what needs to be checked for 450 different kinds of variants. Now it just happens with a digital scanning. So this was the added advantage, that the person who was involved in the checking had to remember so many checkpoints, but now it is just happening with a digital scanning. Can we move to the next slide, please? Okay. In the body shop too, where full body shells are built from panels, automated robotic arms are used for intricate welding operations. So here again, the help of robotic technology is used for the welding purpose. And here also deep learning vision system is used to improve the process quality, so that if there is any defect, it can be addressed on the real-time basis. In the press shop, there was the usage that was done was of AI-based panel crack detection. So if there is any panel cracks which are identified at the early stage in the pressing process, then that can also be addressed very quickly. Then computer controlled line converts the sheet metal into body panels, and this is done with lot of accuracy and consistency. So these were the fruits that Hyundai got by applying the digital technology, this AI and virtual reality, etc. In the engine shops where engines were made, they have used AI-based vision to identify the surface defects, so that they can ensure that their engines are having 100% field quality. Again, staff who are working at the shop floor, they were trained through virtual reality based on immersive technology to ensure that before getting into the floor, they can hang on to the nature of their job. So it is exactly like visualizing that how I am going to perform a particular task on the floor. So that is first they can have a picture virtually in using the technology in their mind, and after that they can easily conduct. Again, all the machines are monitored in line with the digital monitoring system, and there are robot predictive maintenance to identify the failures that are upfront. So here again, automatic robot in the logistic systems is used to carry the parts from one assembly line to the other. And AI solutions using deep learning image analytics in safety for human entry prevention in auto zones in the body and assembly shops. So here the entry of humans is restricted. So through deep learning image analytics, this thing was possible, that AI offered this solution that, okay, here the human entry will be restricted, because if they enter, it would not be safe for them when there is a assembly work of the car that is going on. I hope this is clear. Yes?
Yes, ma'am.
Shall we move on? Yeah.
Yes.
Now, another aspect that they did was, in order to ensure cost savings in the supply chain, they successfully implemented solutions to optimize outbound truck routes and freight structures. So again, here, though here we are discussing about Hyundai, but if we take the example of our Akshay Patra kitchen that is there, which is into midday meals. They are also using technology to map all their vans the routes are decided in such a way that when one van is going, and let's say in the district of Gandhinagar, then it would try to cover maximum schools that are coming on that route. So this is how the cost savings can be ensured. Instead of sending two vehicles at two different places, you are identifying the best route which can be chosen, and only one vehicle can be used. Inventory levels and reorder points are also now decided in Hyundai using AI, where they ensure optimal stocks, and they will be just replenishing the stock when the optimal level, when the inventory goes below the optimal level. Then they have latest tech entry to the plant, a collaborative robot that is, they call it as cobot, and there it is most advanced technologies for product assessment at the smart manufacturing style. Now, as I said that in 4.0, they are also talking about the sustainability part. So what Hyundai did was, they, in terms of sustainability, they are depending on renewable energy, where 64% of its power requirement is sourced through renewable, and they are targeting 100% for the next coming years. So this is where they think about new thinking and new possibilities. So if you can see, if you can sum up on this caselet, it is like they have applied the technology revolution in terms of robotics, virtual reality, then as far as the safety goes, and even the sustainability part. Next one, please. Okay. Now, another thing that we can talk about, how Vistara has used virtual and augmented reality for certain training activities of the staff. They are using chatbots where customers' queries are handled very quickly. So instead of any person being devoted and he is answering to the queries, this is where the Vistara is trying to see how much more self-help can be provided to customers with the help of artificial intelligence. So basic queries like what is the flight status, how much baggage one can carry, right? So all these common questions that are there, or if the flight is delayed, then how much time it will take further for the rescheduling. So all these questions are answered by chatbots with right data, and it is being done very quickly as well. And nowadays, if we see, if you go to any of the institutes website, educational institutes, even they are using chatbots for handling the admission inquiries. Then another case study is of Apple Vision Pro. It uses the concept of mind reading devices into mainstream applications. Now, this vision headset has 12 cameras, 5 sensors, 6 microphones, and it has more than 4,000 per eye video resolution. So here, this high performance eye tracking, how it is being used, that it uses high speed cameras and ring of LEDs that project invisible light patterns onto the user's eyes for responsive intuitive input. So mind reading devices are here, where using this app, one can find that, okay, what is the movement of pupils, what is the heart rates, brain impulses, right? So these will predict your movement, actions, or thoughts. And lenses, sensors, and AI will now soon know what humans want before they know it themselves, right? So this is the power of the technology that is being used. And even this in the Apple phones, right, as in the initial part, it was being pointed out by the participant that it also gives the aspect that, for example, what is the heartbeat. Even the smartwatches are giving these things. But now in the Apple phones, in the latest version, they are trying to even say that, okay, if I'm sleeping at night, then what is the quality of the sleep? Whether it was a deep sleep or it was some disturbed sleep kind of thing. So all this has been possible because of the use of the technology and AI. Okay, would any participant like to add over here any example? Any example from the participant side? Okay, then we move ahead. Now, if you look at Gujarat Heavy Chemicals Limited, what they have done as far as the Industry 4.0 is concerned. So, they are more concerned about making the textile production more efficient. And it is believed that, in textile industry, it is highly polluting, resource consuming industry in the sector. So, how to make it more sustainable? So the first thing that GHCL did was they made a range of textiles that are woven with combination of thread and technology. So this would help to keep the body temperature in control, curtain the ill effects of radiation. And also they are into this linen making. So they are seeing that, okay, the bed sheets that are prepared are also help the people to have quality sleep. So these were the things that were considered. So here the company uses SAP to understand and craft the movements of special fiber. And it again uses fingerprinting technology on the Egyptian cotton yarn by inseminating optically traceable fiber into the fabric, which can transmit data and track the life cycle of the product right up to the recycling it, right? So over here, what happens is that it is Gujarat Heavy Chemicals have taken initiatives to see that, okay, what can be done in terms of this Egyptian cotton. Let me tell you, there are two types of cottons that goes in manufacturing of the clothes and the bed sheets, etc. One is the normal one, our indigenous cotton, and another one is the Egyptian cotton. So they are tracking this data on the usage because how that can be used while making the fabric. Next. Okay. Now the technology has helped to establish the source of cloth and secure complete traceability from gin to store. So here through technology, they can find that, okay, what is the quality of the fiber that is there right from the, we can say from gin to the store. That is the process of ginning the cotton till making a fabric and selling it in the market. So here they have gone for injection of an optical security marker at the gene, where they say it is optical fingerprint and it's only readable by smart lock and key sensors. So the company has created this type of sustainable, we can say the threads or the ginning aspect, and where they have tried to use the PET bottles. They have used the recycled PET bottles to make those fabrics, which can further be used in making the bed linens, the bed sheets, etc. So this helps in reduction of landfill space, crude oil consumption, and carbon emissions. So by using the technology of Egyptian cotton, which can be used for making the fabric, they have also addressed this PET bottles issue, which they are using and making the fabric out of it, and especially making bed sheets out of it, right? Next. Then there is a range of advanced textiles which like using nanotechnology. which has been developed by Department of Textile Technology, and they work on to develop polymer, clay nano composite coated fabric, etc. And this fabric has a lower mass, and has an enhanced ability to retain gases and an improved tensile tear strength. So they are trying to come up with the fabric which can lead to low carbon emissions and has a more strength. So the largest adoption of technology has been for the purpose of reducing the monumental waste it creates, right? So in fabric industry, fashion, it is said that it is the most notorious industry, because garments may be in very good shape, but then if it has phased out of fashion, people do not use it, right? So how to address that fabric waste? Next. So it produces waste at an equally huge scale. And this industry is again using more water. So it is intensively using water. So over here, if we take the example of Arvind Mills, which is based at Gujarat in Ahmedabad, so they have tied up with a retailer called Gap, and they are using their innovations where they can try to use less of water. So they have come up with new water treatment facility where they use fresh water. They eliminate the use of fresh water, and they are actually saving the water. So the treatment will replace 100% of the fresh water consumption. And by doing this, the millions of gallons of water can be saved. So this is how, again, Arvind is working on the aspect of saving the water. Another thing that they have adopted, Arvind has adopted, is just-in-time technology. So what happens in just-in-time? Do you stock the raw material? Do you stock the raw material, etc.?
No, ma'am. As this is just in time, that means only when it's required, it's refilled by the vendor. That is the
Exactly.
reason GIT is used.
Yes.
So we need to have a reliable set of vendors who are aware about the technical specification to supply on time, so that warehousing and then taking it to the factory, that time and cost is saved.
Exactly.
Thank you,
So,
ma'am.
yeah, thank you for the value addition. So over here, by using, can we go to the next slide? So they want that the production of garment starts only after consumers places the order, and once the order is received, they can start the printing of the fabric, cutting it, stitching it, etc. Right? Yes. So it's a pull system. Yes, exactly. And not a push system. So instead of stocking the items or the raw materials or semi-finished goods in the warehouses, the company tries to now even offer the products on website as per the availability of raw material, and also have better control on the demand cycle. So it's like, this is what we have, and let the demand come accordingly, we will be preparing. Another thing is another initiative which is taken by Aditya Birla Fashion and Retail Limited. It announced that electronics giant IBM will help them in infrastructure as a service in a private cloud environment. So what kind of services IBM will give to Aditya Birla? So it is like it would enable the company to scale its IT operations in line with the business growth. And there are many outlets that Aditya Birla has in India, and many brands that it has created. So there are more than 2,000 exclusive outlets in the country. Now, any brick and mortar stores will involve a lot of investments. So how the technology would be used here? Any idea? How the technology would be used?
Like this, Aditya Birla is already using it to sell its products on Amazon.
Amazon, yeah.
Because they can directly sell it to their customers, and you're getting at almost half the price that you get in stores. So that is the IT infrastructure they have already scaled up. Because I'm buying it because I like to buy brands like Louis Philippe and Van Heusen, which is expensive if you buy it in store, and if you go online to their own stores of Van Heusen and Louis Philippe, you get it almost 50%, sometimes even 40% of the price. So you can buy more.
More,
And
true.
yeah, and so
So,
it's sustainable as well, because you don't need to go out and spend time, and you can spend that time on more on other things, like as teachers, we can spend it on research rather than going to the shop and buying something.
Exactly. So, this is where the company is using the technology. They are saving not only in terms of capital investment, but also on their operating working capital investment, right? Where they can reduce their operating cycle. Can we go to the next slide, please? Yeah. So the apparel measures what this Aditya Birla is doing. They are using the tech applications in which includes digitizing clothing samples instead of producing actual samples for dealers and wholesalers. So, generally, when you go to any textile industry, they have a book of the samples where they actually have those small cut samples, which is put in a album kind of thing. So now, instead of having those physical samples, they are going for digitizing the cloth samples. And this approach has reduced their wastage, and it also helps to reduce go to market time of the products by almost 5 months. So the dealers or the wholesalers can directly digitally choose the sample. Then they will start making the finished product, and the lead time that is there, or we can say the time that is there to provide the product to the customer has also reduced. Another thing is online retailers as well as brick and mortar outlets. They have introduced digital trial rooms to help the customers experience the shopping differently. So again, this is the use of the technology that has been done. Then there is one stereolithography, which is being now used in the 3D printing. Okay, where you are using a plastic-like liquid that is solidified by a laser. This was the innovation which was which was done by US. And the biggest change in the apparel industry is likely to be around smart wearable clothing, which has so far remained only a concept or a high-end investment, which is now going to come up in the near future. And this particular stereolithography, this was used in printing one of the gown of the famous actress Miss Deepika Padukone during one of the celebrity show that had happened, right? So can we move to the next slide, please? So these are the couple of initiatives which was understood through like how technology helped the companies. Now, case study of L'Oreal is very interesting. It says that new trends are responded in less than 6 months versus 18 months. So now they are able to address, in fashion and this cosmetic industry, every time innovation is important, and secondly the speed with which you give the products to the market is also equally important. So L'Oreal is now I would say it's a turnaround. Like earlier it was 18 months, and now it is just the 6 months during which the products are rolled out, getting closer to fast fashion type of approach. So fashion, and we are putting the word before prefix before it, that is fast fashion approach has been adopted. Now, how L'Oreal has used 4.0 and how it has revamped its business. So they have used 4.0 in business of packaging, purchasing, manufacturing, supply chain. They have harnessed new technology. They've used IoT, connected objects. They've also used augmented and virtual reality and artificial intelligence. So now the business models are not based on economies of change. They are based on redesigning the value chain. So I would say that with the industry revolution, that is 4.0, here the important part is, earlier we used to talk about economies of scale, economies of scope, etc. But now it is more about how we are redesigning the value chain. Next, please. Okay, so now what L'Oreal has done to manage the shorter product life cycle, new technologies are introduced at the different stages, and they have accelerated the design process. For instance, approval of prototypes in the project phase. So it's not about like you are, the phase has happened in such a way that prototypes itself are approved. The pace with which the prototypes are made, even that process has been accelerated instead of building models and testing products in the real world. So earlier it was the concept, like we said, test marketing. You make the product and then you give to the customers, few set of customers, they will give the feedback, then you decide on revamping. Please just take the previous slide. Please take the previous one. Can you just go back to the previous slide? So I'll just talk about over here. Is it possible to go to the previous slide, please? Yes. So earlier it was like test marketing of the product. Now they are doing it on the prototype. They're developing 3D models, which are just a virtual simulation, I would say. Drop, transport and resistance, virtual merchandising and other tests, all these things are saving a lot of time for L'Oreal, right? So they are, earlier it was like the prototype is made, the product is made, samples are made, then it is transported, and then further in the test marketing, whatever resistance is coming, they are further changing it. Now it is all happening on the basis of the prototypes. Next slide, please. Another part is that connected products. Can we go to the next slide? So under connected products, the goods are more traceable and they are offered to the end customers with great transparency. Now, what L'Oreal is doing is that given its sales, it has $1 billion sales. So L'Oreal uses the connectivity to optimize its supply chain through a global vision of inventory, and they facilitate day-to-day point of sale, that is POS, product management, where they talk about the reception, collection and inventory. They have also connected products. The connected products are also a way to forge the closer ties, and they enhance contact and interaction with customers through direct product or through phone dialogue, right? So this is again in test marketing, multiple times you are doing it, but using the prototype and connected products, the feedback is taken on a quicker basis. Can we move to the next slide, please? Okay, next one. Now, consumers' demands becoming, the demand of the consumers is changing, and it is vital to be able to switch easily from one production run to another in response to shifting trends. So earlier this was a little difficult part, but now with the advent of technology, they are easily able to address the changing demands. The first 4.0 pilot projects launched at facilities in Italy, France, and USA, they have yielded a very positive result from new agile production line, where they create and produce in a manner that is more flexible and adaptable than the traditional methods. And new product lines have also been able to manage final product differentiation, like as it is into cosmetics. So differentiation matters a lot in terms of shade, labeling, etc. And later this differentiation has also gone to the value chain, right? So it is more of like they are able to use this technology. They are able to build the prototypes where they can showcase the different shades, etc. Now, customization is another trend which is very popular. So young people even want to get in on creating their new products. So it is like, I would say, mass customization. And now they can have this point of sale co-creation opportunities where the consumers can manufacture their own cosmetic products in store, or have a personal message that they can have it engraved on the fragrance bottle, right? So again, here the technology is being used where the customer is given the liberty of creating their own product. So it is not about buying the product, but it is about experiencing experiential marketing, which is being pushed through the technology. Again, in addition to B2B channels, L'Oreal is now turning its focus on B2C. So what is the demand of the customers? They want their products anytime and anywhere. So it makes sense that there should be a focus on e-commerce, which is a major focus for the group. And it occupies a growing share of sales because it is having its presence on e-commerce platform. Data management facilitated by artificial intelligence has a profound influence on L'Oreal value chain. Faint signals on social media and data gathered at POS, all this information, they derive a lot of insights out of it, and they use this, they analyze it to understand that, okay, which are the factors which are influencing the buying behavior of customers, where they need to improve the product. And it further also helps to anticipate the trends and optimize their sales. Digital transformation has also been so encouraging, where the operation personnel are adapting constantly to meet the consumer demands, and they are also taking up new novel projects in the disruptive ways. Okay, can we go to the next slide? Yeah. Another one, if you talk about the sustainability part, as I said, that Industry 4.0 is also addressing the sustainability. So I've taken the examples over here that what companies are doing as far as sustainability is concerned. So the homegrown FMCG brand, Ayurvedic brand Dabur, basically, it has started collecting the plastic waste. They have started processing, recycling, and they are making more, recycling more plastic waste than what they are actually selling in terms of product packaging. Similarly, ITC has also taken up sustainable packaging for plastic substitution, and it has announced that it will reduce the utilization of plastic across the products, right, from the packaging and food to the hotel business. Similarly, please take the previous slide. Yeah, similarly, if you take the case of Coca-Cola, then it has also launched new bottles that are made from recyclable plastic, so rPET bottles. So that is again, they have a goal that at least 50% recycled content they would be using in the in making this rPET bottles, right? Next. Okay. Then ITC's paper boards, paper and packaging business also, they are also the pioneer in sustainable packaging, and they want to substitute the single-use plastics because it adds a lot of landfills. And it has extended its sustainable packaging initiative to its own personal care products such as well. And ITC's personal care brands, they are also adopting recyclable options like Fiyama shower gel bottles. They are now using 50% post-consumer recycled material, while Savlon glycerin soap are using 70% of the recycled plastic pet layer. Then their Engage perfume and other means whatever brands that they are selling, either they have the rpet bottles that are being used, or they are trying to minimize the single use plastic. Even ITC's hotel business, they are now replacing the plastic water bottles with the eco-friendly glass bottles. And going back to Dabur's example, they are processing and recycling more plastic waste than what they are actually using in packaging. And this is where it includes all the types of plastic waste, from PET, HDPE bottles, PP caps, and labels, to multi-layered plastics and beverage cartons, right? Next slide, please. Okay. The DS Group, which owns FMCG brands like Catch and Pass, they have also said that they are taking various sustainability initiatives in the areas of energy management, water management, material conservation, recycling, and ultimately the main thing, the end result of sustainability is to reduce the carbon footprint and enhance the green footprint. So again, Saint Gobain glass manufacturer, a leading glass maker, they have also announced to launch a production of new glass with a low carbon footprint. And approximately they want to reduce the carbon footprint by 40%. So these are some of the initiatives in terms of sustainability that are being talked about. Next. Okay, now before we go ahead, any case studies or any example which the participants would like to share? Anyone?
Ma'am, there is one thing in the milk industry where we use much more of plastic bags.
Yes.
It's not actually one company, but various farms have now come up where they use glass bottles. And I've been using glass bottle milk for the past, say, 6.5 years. And I think they're more sustainable. And I generally, only in emergencies, I go for those plastic packaged milk.
Exactly.
So that can personally also, everybody can contribute to the sustainable development or the sustainability. In the long run, even big companies like Mother Dairy and Amul should go away from using plastic. That is only sustainable, because more and more plastic means more and more waste. Even if you're packaging less and recycling more, then also you are actually increasing the plastic, the environment. And we should personally go and do this. Everybody should try to at least try to buy milk and other products which are not packed in plastic, because earlier it was very sustainable. Brown paper was used, and we have gone away from that because we are more into easy things, and we should not be easy, because easy ultimately kills us.
Kills us, true. And even yes, somebody is pointing out that while ordering online food apps, they also ask whether you need any cutlery and no paper bill option. So yeah, these are the initiatives where we can use technology. We should substitute technology instead of the physical resources.
Yeah, and mainly, like, if you go to buy vegetables, people will try to take polythene bags. It's better to take the cloth bags and go, and we can sort out the vegetables later. Even like sorting out, they take the bag, go, and then again take the plastic. So it's not sustainable.
Not
If you're
sustainable.
taking the cloth bag, then because I have seen in my childhood, because now generation will not understand, where my grandmother used to go out and then we used to come back and sort the vegetables. We used to help. So that also helps in the becoming more social rather than being very. So that can be a case study in general. We can teach them to students.
In fact, they don't consider it to be a status symbol to carry a cloth bag. So if not cloth, they can go with the jute bag, right? And in fact, in Ahmedabad, there is one of my PhD student. She runs an NGO, and her NGO is into making this type of bags which are compartmentalized. So if you go with a shopping bag, especially for buying the vegetables, generally in a cloth bag also, what is the problem? We buy all the vegetables and then we have to do the sorting. So there she has made a bag which has a little compartments where one can put in one space area devoted, let's say, where they can put some 1 kg of potatoes or 500 grams of tomatoes, etc. And so the sorting then is not required. So this, and she said, I told her that why you are not marketing it on a large scale. So she said that without even marketing the product, I am getting huge orders out of it. So this is
There can be, there's an idea which I have, which I've not been used. Like you can have separate bags, small bags rather than compartmentalizing. Because we don't know how much tomato we're going to buy. We don't know 500 grams or 1 kg. Depends upon the price in the market. We can have like, we can brand it like tomato and then potato. It look nice. Also, people will not have that problem of like having the status symbol. That will become a status symbol.
True, very true. So all said and done about the industry 4.0, what are the emerging, can we have the previous slide? Yeah. So here, emerging digital ecosystems, here we need to have new mindsets, new capabilities, and new skills. So smart manufacturing would be as the unity of data, technology, environment perspective, economic growth. All this needs to be understood as a part of smart technology. Again, digital will be a cutting edge where deep understanding of digital platforms, how customers can participate in, or employees use for continuous learning, artificial intelligence, machine learning. All these are the things which the upcoming skills basically is required. Next slide. Yeah, new digital production line skills that will be needed. Like earlier, we used to say that planning, operating, controlling, directing, all these are, the functions of the management, right? But now it is becoming like digital production line skills, not only the conventional ones, but these ones where maintenance, warehousing, material planning, using 3D printing, robotics, how this can be learned, virtual reality, augmented reality, training the shop floor engineers, and fault diagnostics, all these parts, how we can reduce the kind of, we can say, wastage or defects, right? All this can be addressed through using of the use of technology. Even at workman level, the capabilities are there which are needed to address for training the workmen for the robotic process, etc. And the food for thought now lies that can we have a kind of understanding that there is nothing which is stagnant. Continuously there is a change, and this will keep our mind proactively looking for ideas for constant improvement. So it could be a Kaizen day where we think, even while our delivering of the sessions in the class, can we think of bringing this type of case studies? Of course, we are management teachers, so we might not have that flair for understanding the engineering part, but at least the marketing and the financial part that can be addressed while teaching. Secondly, follow your passion. If you are going to be spending the best part of your productive life at formal workplace, then you must enjoy that every minute. So this calls for learning new skills, like we should know the Python or R, or stuffs like that, where we can make our students ready for it. Thirdly, be an enthusiastic team player. Except in very specific cases, a combination of both the qualities, brilliance and teamwork, would be a blend. So this could be taught to the students, that only having, of course, guts to do the work is important, but how you are fitting in the teamwork with your exceptional qualities, that is also important. And fourthly, always think and act with sustainability and circularity in the mind. So here I would like to share one small example. There is one more NGO in Ahmedabad which works on, there is lot of cloth waste that is being generated. If we go for, stitching our own clothes, then at the boutique or at the tailor shop, there are a lot of cloth waste. Now these NGO are collecting this cloth waste and they are making beautiful handbags out of it. So this is one way that if one action I will take, what will be the sustainability repercussion, and how it can be then recycled and resource can be saved. Another example is like nowadays we are not having the pens with refills, right? I mean, it is more of use and throw. We are not refilling the pen with a new refill. So there is one more NGO in Ahmedabad which works on this aspect, that at every institute they are putting the bins. So when the students have used up their ball pens, they can just put in that bins, and then they are making some small paperweights and things like that from that recycled pen plastic. And finally, we have to keep abreast of technology and technological changes. And this is where we try to make technology our friend. Maybe on real-time basis, we want to circulate the assignment and print is not possible. So we can there use take the help of the WhatsApp group. So this is where we can integrate we are into more of a service industry. So we can integrate the technology in terms of delivery, in terms of sharing the experiences that the companies or the corporates have done. So this will be a think tank for the students further, right? Now, this was this is an end to whatever I had to say. This was all from my part. Now, any other thing that a participant would like to share?
I'm there again, ma'am. Like in our college, also we use technology while assignments. Like we reduce the paper. Like it's on ERP. We get it in PDF and we check it, and then documentation also needs to be done. So only selective assignments are we tell them to like print it and then sign it and submit to us. By that we are actually saving trees. So we are using technology to reduce waste. So that is a very good what I found is done in our college. ERP is being used for reducing the waste. So you don't have to. I also do not discourage students to tear paper from their notebooks.
True. And in
that
fact,
should be discouraged.
At our university, the students who are writing the exam, then university scans the answer book and sends for the correction purpose. So they are saving on the transportation cost basically. So these are the initiatives that one can think of, right? So any feedback?
Yes, ma'am. It was very nice session. Learned a lot. I do like to do research on the, so I knew a few things, but I also learned a few things, and that's how an FDP is. So it was an excellent session. Thank you.
Yeah, thank you so much. Actually, I am so happy that first of all, Sarvishta madam gave me this opportunity. And secondly, we have a lovely audience, madam, they are so interactive and, sharing their thoughts. It was really great.
I would like to thank
May I, ma'am?
Jigna madam. I think she is still in office, to take the session. As far as I know her, I mean, a wonderful, very, very meticulous individual. And I'm so thankful to you, ma'am, for taking out time for us. And the session was really nice. I hope all the participants enjoyed the session as much as I did. We will, with your permission, ma'am, I have your PPT with me. We plan to share all our resources with the participants. So I'll share your PPT as well with them.
Okay. Thank you so much.
Yes.
Thank you so much, Digna ma'am. It was really wonderful to hear you, and the knowledge which you shared was exemplary. And I must say that change is the only constant thing that we must realize and we must acknowledge. And with the changing times, one must also be able to adapt to those changes. So, after all, FDP is a platform to share our experiences, cultivate the relationships, overall to strengthen our academic community. And I think everybody here will agree with me that this has been really an enlightening session for all of us.
Yeah, thank you so
May
much.
I, ma'am?
Yes,
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 ma'am.
please, ma'am.
Yeah, ma'am, I would like to thank Jigna ma'am for being so patient given that initial bottlenecks and how we started with discussion. And throughout the time, she was smiling and she was struggling also to share the slides. That way really shows that how she's a seasoned academician, how she was handling and encouraging everyone to share their experiences and case study. That way, I really would like to really thank ma'am for involving all of us to make this fruitful. Because
Thank
late in the evening, when everyone is so tired and really developing, so we all want to upskill ourselves. And how you become the reason to make me stop eating my food and cooking my food so that I can attend you. Thank you so much, ma'am.
Thanks for attending. Okay. So,
So, thank you so much, ma'am. We really were honored with your presence. With this, today we end our session, but tomorrow again we have two more sessions lined up. I'll share a brief review of who will be joining us tomorrow, and everybody, I think, will be very excited as much as they are today. Do not forget to fill up our feedback form before logging out for tomorrow. So tomorrow we'll have Dr. Hayan Nassar Wankit from Malaysia gracing us with his presence. We'll see you tomorrow again at 6 p.m. followed by we'll be having Professor Ramakrishna Yamachali from, I think he's from Karnataka, but both of them will be here tomorrow in the same thrust of the FDP, which we'll be sharing with all of you tomorrow. See you again, and thank you so much for joining us. It was a wonderful experience.
thank you, ma'am. Okay. Bye, everyone.